Hello there, and welcome. Tonight I want to take you somewhere beyond the familiar stars, beyond the comfortable boundaries of what we think we know about existence itself. Settle in, make yourself comfortable, and let your mind drift with me into the vast cosmic ocean where mysteries float like islands of light in an endless sea of darkness. We're going to explore something together, you and I, something that might fundamentally change how we understand our place in the grand tapestry of reality. It's a question that might seem impossible at first, perhaps even absurd to consider. But what if the universe we call home, this magnificent expanse of galaxies and nebulae that stretches 14 billion light-years in every direction, what if it's just one room in an infinite cosmic mansion? And what if, just maybe, we've recently had our first visitor from another room entirely? Consider this for a moment as you breathe slowly and deeply. Every star you've ever seen, every galaxy captured by our most powerful telescopes, every particle of matter and wave of energy that we've ever detected or theorized about, all of it might exist within just one cosmic bubble among countless others. Each bubble born from its own Big Bang, each one following its own rules, its own physics, its own destiny. And floating through our solar system right now, or rather, having recently passed through like a ghost ship in the cosmic night, might be an object that originated not from another star, not from another galaxy, but from another Big Bang entirely. This visitor has a name, a rather unglamorous scientific designation that hardly captures the profound implications of what it might represent. We call it 3 Atlas, and it might be the most important discovery in the history of astronomy, though most people have never even heard of it. Now, I know what you might be thinking as you lie there in the darkness. How could we possibly know if something came from another universe? How could we even detect such a thing? These are good questions, natural questions, and we'll explore them together with the patience and wonder they deserve. But first, let me paint you a picture of the cosmos as we've understood it until very recently. For decades, we've believed that everything that exists emerged from a single point about 13.8 billion years ago. In that first moment, smaller than an atom yet containing all the energy that would ever exist, space itself began to expand. Not an explosion into space, but an explosion of space itself. Time began its steady march forward, matter condensed from pure energy, and the first particles began their cosmic dance that would eventually lead to stars, planets, and on at least one small world, to conscious beings capable of contemplating their own origins. This story of the Big Bang has been one of science's greatest triumphs, a theory supported by countless observations and measurements. We can see its echo in the cosmic microwave background radiation that fills all of space, a faint whisper of that primordial fireball still reverberating through the universe. We can measure how galaxies are flying apart from each other, carried by the expansion of space itself, and trace their motion backward to that singular beginning. Everything we observe seems to confirm this picture of a universe with a definite beginning, a specific age, and laws of physics that have remained constant throughout cosmic history. And yet, perhaps this magnificent story is just one chapter in an infinitely larger book. You see, as our understanding of physics has deepened, particularly our grasp of quantum mechanics and the behavior of space and time at the smallest scales, we've begun to realize that our Big Bang might not have been unique. The same quantum fluctuations that gave birth to our universe could be happening elsewhere, elsewhen, in ways we're only beginning to imagine. Picture, if you will, an endless ocean of potential, what physicists sometimes call the quantum foam or the multiverse landscape. In this ocean, bubbles occasionally form, each one expanding into its own universe with its own Big Bang. These bubbles might have different physical constants, different numbers of dimensions, different types of particles and forces. Most would probably be sterile, unable to support the complexity needed for stars and planets. But some, perhaps many, might be as rich and varied as our own cosmos, just following different rules. This isn't science fiction or wild speculation anymore. Many of the world's leading physicists and cosmologists take the possibility of multiple universes very seriously. The mathematics of inflation theory, which explains how our universe expanded so rapidly in its first moments, naturally leads to the prediction of other universes. String theory, our best attempt at unifying all the forces of nature, suggests there could be 10 to the 500th power different possible universes, each with its own unique physics. That's a number so large that if you tried to write it out, you'd need more atoms than exist in our entire observable universe just to print the zeros. And somewhere in that incomprehensible vastness of possibilities, there might be universes similar enough to ours that matter could form, stars could shine, and perhaps even life could emerge, yet different enough that their artifacts would carry subtle signatures of their foreign origin. Which brings us back to our mysterious visitor, 3 Atlas. But before we delve into its peculiar properties and what makes it so special, let me share something with you about how we detect objects in space, especially those that don't emit their own light. It's a process that requires patience, dedication, and increasingly sophisticated technology. Every night, all around our planet, telescopes scan the heavens, taking image after image of the same patches of sky. Computer algorithms compare these images, looking for anything that moves against the fixed background of stars. Most of what they find is familiar. Asteroids tumbling through the asteroid belt, comets falling in from the outer solar system, the occasional piece of space debris from human activities. But every once in a while, something appears that doesn't fit any known category. The first interstellar object we ever detected was Oumuamua in 2017, a name that means scout or messenger in Hawaiian. It was moving too fast to be bound to our sun's gravity, which meant it had to have come from somewhere else, another star system at minimum. This alone was extraordinary, the first confirmed visitor from interstellar space. But Oumuamua was just the beginning, a hint that our solar system might be receiving visitors more often than we ever imagined. And then, in 2019, came 3 Atlas, moving even faster, on an even stranger trajectory, with properties that made some scientists wonder if we were looking at something far more exotic than just another interstellar rock. The detection of 3I Atlas began like any other astronomical observation. The Atlas system, which stands for Asteroid Terrestrial Impact Last Alert System, consists of telescopes in Hawaii designed to spot potentially dangerous asteroids. On a clear night in August 2019, the system flagged an object moving through the constellation of Cassiopeia. At first, it seemed like it might be just another comet, perhaps one from the outer reaches of our own solar system. But as astronomers calculated its orbit, they realized something extraordinary. This object was moving at a velocity of over 180,000 miles per hour relative to our Sun, far too fast to be gravitationally bound to our solar system. Like Oumuamua before it, this was an interstellar visitor. But unlike Oumuamua, 3I Atlas was still approaching, giving scientists precious time to study it in detail. As telescopes around the world turned to observe our visitor, strange details began to emerge. The object's spectrum, the fingerprint of light that tells us what something is made of, showed unusual features. There were absorption lines that didn't quite match any known minerals or ices. The way it reflected sunlight suggested a surface, unlike any asteroid or comet we'd catalogued. And its trajectory, when traced backward, didn't seem to point to any particular star or stellar nursery. It was as if 3I Atlas had emerged from the empty space between galaxies, from a void where nothing should exist. Some scientists began to wonder quietly, in hushed conversations at conferences and in speculative papers posted to preprint servers, whether we might be looking at something truly unprecedented. Now, as you drift there in the darkness, perhaps feeling yourself beginning to relax into the rhythm of these words, I want you to consider what it would mean if 3I Atlas really did come from another universe. Not just another star system, not just another galaxy, but from a completely separate cosmos with its own Big Bang, its own history, its own laws of physics. How could such a thing even be possible? To understand this, we need to venture into some of the strangest and most beautiful ideas in modern physics. ideas that challenge our very notions of reality, existence, and the nature of space and time itself. In our everyday experience, space seems solid and continuous. We move through it, we measure distances in it, we navigate by it. But at the quantum level, space might be very different. Some theories suggest that at the smallest possible scale, smaller than atoms, smaller than protons, smaller even than quarks, space might be a seething foam of quantum fluctuations. In this foam, tiny wormholes might constantly form and disappear, connecting different regions of space or even different universes for brief moments. Most of these connections would be smaller than subatomic particles and would last for times shorter than we can measure. But perhaps, under certain conditions, some of these connections might be stabilized, might grow, might even allow matter to pass through. There's another possibility too, one that emerges from our understanding of cosmic inflation. During the Big Bang, our universe underwent a period of incredibly rapid expansion, growing from subatomic size to larger than a grapefruit in a fraction of a second, so small we don't even have words for it. This inflation was driven by a field of energy that filled all of space. But here's the fascinating part. In many models of inflation, this process doesn't happen just once. Instead, inflation is eternal, always happening somewhere. Our universe would be just one pocket where inflation happened to stop, allowing matter to form and stars to shine. But elsewhere, inflation continues, spawning new universes constantly. And at the boundaries between these pocket universes, at the places where one universe's inflation has stopped but another's continues, there might be regions of overlap, zones where matter from one universe could theoretically cross into another. Imagine, if you will, two soap bubbles floating in the air, drifting closer until they touch. At the point where they meet, their surfaces merge for a moment, creating a temporary bridge between their interior spaces. Now, scale this image up to cosmic proportions, where each bubble is an entire universe, and the point of contact might last for millions or billions of years. During this time, objects near the boundary might be pulled through, especially if they're small enough and moving fast enough. They would emerge into the new universe carrying subtle traces of their origin, like a traveller bearing the dust of distant lands. This isn't just abstract theorizing. Physicists have calculated what would happen at such boundaries, what kind of forces would be at play, what kind of objects could survive the transition. The mathematics is complex, involving concepts from general relativity, quantum field theory, and cosmology. But the basic conclusion is surprising. Under certain conditions, it might be easier for an object to pass between universes than we ever imagined. The object would need to be relatively small to avoid being torn apart by tidal forces. It would need to be moving very fast to punch through the boundary before it could be repelled, and it would need to be made of stable matter, able to survive the extreme conditions at the interface between realities. 3 Atlas meets all of these criteria. It's small enough, just a few miles across based on our observations. It was moving incredibly fast when we detected it, faster than almost any natural object we've seen in our solar system, and spectroscopic analysis suggests it's made of remarkably stable materials, possibly including exotic minerals that could only form under extreme conditions. But perhaps the most intriguing evidence comes from its trajectory. When astronomers trace the path of a typical interstellar object backward, they can usually identify a general region of origin, a star cluster or stellar association, where the object likely formed before being ejected. But 3I Atlas's path leads back to nowhere, to empty intergalactic space where stars don't form and objects shouldn't originate. Unless, of course, it didn't originate in our universe at all. Consider the implications of this possibility as you let your mind wander through the cosmic darkness. If 3I Atlas came from another universe, it means that the boundaries between realities are more permeable than we thought. It means that our cosmos, vast as it is just one island in an infinite archipelago of universes. It means that we're not as isolated as we believed. that there might be a constant, if rare, exchange of matter and perhaps even information between different realities. Every meteor shower, every unusual cosmic ray, every anomalous particle detected in our accelerators might need to be re-examined with this possibility in mind. But let me take you deeper into this mystery, into the specific properties of 3I Atlas that have scientists so intrigued. When light from our sun hit the object, it didn't just reflect back normally. There were subtle phase shifts in certain wavelengths, as if the atomic structure of the material was slightly different from what we're used to. Not dramatically different, not alien in an obvious way, but shifted just enough to suggest that the fundamental constants governing atomic behavior might have been slightly different where this object formed. The fine structure constant, which determines how electrons orbit atomic nuclei, might have been a tiny fraction different. The strong nuclear force, which holds atomic nuclei together, might have been marginally stronger or weaker. These differences would be too small to prevent matter from forming or chemistry from working. A universe with such slightly altered constants would still have stars and planets, still have rocks and ice, and maybe even life. But everything would be subtly marked by these differences, carrying an indelible signature of its origin. It's like how a skilled geologist can tell where a rock formed by examining its mineral composition and structure. Each location on Earth has its unique geological signature based on local conditions when the rock formed. Similarly, each universe would have its unique physical signature based on the fundamental constants that emerge from its particular Big Bang. The more scientists studied 3I Atlas, the more anomalies they found. Its density was unusual, not matching any known class of asteroids or comets. It seemed to be releasing traces of gases that spectroscopy couldn't quite identify, molecules that were almost familiar but not quite right, as if they were composed of isotopes that shouldn't exist, or molecular bonds that were stressed in unusual ways. The object's albedo, its reflectivity, changed in unexpected patterns as it rotated, suggesting a surface composition unlike anything in our solar system's inventory of objects. And perhaps most mysteriously, it seemed to be experiencing a slight acceleration that couldn't be explained by solar radiation pressure or outgassing, as if it were being pushed by forces we don't fully understand. Now, I should mention that not all scientists agree with the exotic interpretation of these observations. Science progresses through skepticism and debate, and extraordinary claims require extraordinary evidence. Many astronomers argue that 3I Atlas is simply an unusual interstellar object from our own universe, perhaps formed under conditions we haven't encountered before. They point out that our sample size of interstellar visitors is still tiny, just 2 confirmed objects so far, hardly enough to establish what's normal and what's truly anomalous. They suggest that the spectroscopic oddities could be explained by unusual minerals formed in the extreme environment around a dying star, or by cosmic ray bombardment during millions of years of interstellar travel. These are valid points, and the debate continues in scientific journals and conferences. But even the skeptics admit that 3I Atlas is unlike anything we've seen before, and that it challenges our understanding of what kinds of objects can form and survive in space. Whether it's from another star system or another universe, it's expanding our knowledge and forcing us to think in new ways, and perhaps that's the real gift of this mysterious visitor. Not definitive answers, but better questions. As you lie there, perhaps feeling your breathing becoming slower and more regular, your mind beginning to drift like a ship on calm seas, think about what it means to live in a time when such questions can be asked. For all of human history until very recently, we could only wonder about other worlds in the abstract. We could see the stars but couldn't know if planets orbited them. We could imagine other universes but had no way to test if they existed. Now, in just the past few decades, we've discovered thousands of planets around other stars. We've detected gravitational waves from colliding black holes billions of light years away. We've mapped the cosmic web of dark matter that shapes the large-scale structure of our universe. And now, perhaps, we've caught our first glimpse of something from beyond our cosmic horizon entirely. The story of Three-Eye Atlas is still being written. As I speak these words to you, somewhere in the darkness between Mars and Jupiter, this enigmatic object continues its journey through our solar system. It's already passed its closest approach to the Sun and is now heading back out into interstellar space, gradually accelerating as it climbs out of our Sun's gravitational well. In a few years, it will be beyond the reach of our telescopes, returning to the vast darkness from which it came. But the data we've collected, the measurements and observations and spectra, will be studied for decades to come. Each analysis might reveal new details, new anomalies, new hints about the true nature and origin of our visitor. Future telescopes, more powerful than anything we have today, might be able to detect more such objects. The Vera Rubin Observatory, currently under construction in Chile, will survey the entire visible sky every few nights, potentially discovering dozens or hundreds of interstellar visitors. Some of these might show even clearer signs of exotic origin. We might find objects with isotope ratios that are impossible under our universe's physics, or materials that could only be stable if fundamental forces were different. We might even find artifacts that are clearly artificial, products of intelligence from another reality entirely. The possibilities are as endless as they are mind-bending. But for now, in this quiet moment, we have Three-Eye Atlas, our mysterious messenger from the unknown. Whether it's from another star, another galaxy, or another universe entirely, it reminds us that we're part of something far larger and stranger than we can fully comprehend. Every atom in your body, every element except hydrogen, was forged in the heart of a dying star. You are literally made of cosmic dust, assembled by the forces of nature into a pattern complex enough to contemplate its own existence. And now, perhaps, you're contemplating the existence of other universes, other realities, other versions of existence itself. The ancient philosophers spoke of the music of the spheres, the idea that the cosmos produced a kind of harmony that we could sense but not quite hear. Modern science has shown us that space is indeed filled with waves and vibrations, gravitational waves from merging black holes, electromagnetic radiation from spinning pulsars, the quantum fluctuations of empty space itself, and now, perhaps, we're beginning to detect an even deeper music, the harmonics of multiple universes resonating against each other, occasionally allowing a note from one symphony to drift into another. As we prepare to journey deeper into this cosmic mystery, to explore the impossible characteristics of our visitor in greater detail, let yourself sink into the profound peace of cosmic perspective. Whatever troubles or concerns you carried with you into this moment, they're part of a story so vast and ancient that they're both infinitely important and infinitely small. You're a conscious observer in a universe that might be one of infinitely many, a witness to mysteries that previous generations could only dream about. And in this moment, as your consciousness hovers at the edge of sleep and wakefulness, you're connected to something far larger than yourself, far stranger than everyday reality, far more wonderful than we ever dared imagine. The story of Three-Eye Atlas raises questions that touch the very foundations of physics and philosophy. If objects can travel between universes, what else might be possible? Could information pass between realities? Could the laws of physics themselves bleed across boundaries, creating regions of space where reality itself is hybrid, combining features of different universes? These aren't just abstract philosophical musings anymore. They're questions that scientists are actively investigating, using the tools of mathematics and observation to probe the deepest mysteries of existence. In particle accelerators around the world, physicists smash particles together at energies approaching those of the Big Bang itself, looking for signs of extra dimensions or parallel realities. They've found hints, tantalizing anomalies that might suggest our three-dimensional space is embedded in a higher dimensional reality. Some particles seem to disappear, possibly slipping into dimensions we can't directly perceive. Others appear from nowhere, possibly crossing over from parallel dimensions. The evidence is subtle, indirect, but it's accumulating year by year, experiment by experiment. Cosmologists studying the cosmic microwave background, that faint echo of the Big Bang that fills all of space, have found unusual patterns that some interpret as evidence of collisions between our universe and others. These cosmic bruises, as they're sometimes called, appear as circular patterns in the temperature of the background radiation, places where our universe might have bumped into another during the chaotic early moments after their respective Big Bangs. If these interpretations are correct, then 3i Atlas wouldn't be our first contact with another universe, just our first tangible visitor. The mathematics of string theory, our most ambitious attempt to describe all of reality in a single framework, requires extra dimensions beyond the 3 of space and 1 of time that we experience. These extra dimensions might be curled up smaller than atoms, invisible to our everyday experience, or they might be vast, containing other universes floating like membrane worlds in a higher dimensional space. In this picture, gravity might be the only force that can leak between universes, which could explain why it's so much weaker than the other fundamental forces. What we perceive as weak gravity might be full-strength gravity, diluted by spreading across multiple dimensions. Some theorists have proposed that black holes might be gateways between universes. When matter falls past the event horizon of a black hole, it might not be destroyed, but rather transported to another reality. The information paradox of black holes, the question of what happens to information that falls in, might be resolved if the information is preserved in another universe. 3i Atlas's trajectory, when extended far into the past, passes suspiciously close to several known black hole positions. Could it have emerged from one of these cosmic gateways, carrying with it the physical laws of another reality? The implications extend even further when we consider time itself. In our universe, time flows in one direction, from past to future, driven by the increase of entropy, the tendency of things to become more disordered. But in another universe with different initial conditions, time might flow differently. It might move faster or slower, or even in reverse from our perspective. An object from such a universe wouldn't just be from another place, but from another kind of time entirely. Its atoms might age differently, its radioactive elements might decay at unusual rates, its very existence might be a kind of temporal paradox that our physics struggles to describe. 3 Atlas exhibited some temporal anomalies that support this wild speculation. Radioactive dating of the gases it released suggested ages that didn't match up, as if different parts of the object had experienced different amounts of time. Some isotopes that should have decayed billions of years ago seemed fresh, while others showed more decay than should be possible given the age of our universe. It's as if the object existed in multiple time frames simultaneously, or had passed through regions where time itself flowed at different rates. As you drift deeper into contemplation, feeling perhaps the gentle pull of approaching sleep, consider how this changes our understanding of our place in existence. We've always known we were small compared to our universe, tiny conscious beings on a pale blue dot orbiting an ordinary star among hundreds of billions in our galaxy. But if the multiverse picture is correct, our entire universe is just one bubble in an infinite foam, one note in an endless symphony, one story in a library that contains all possible stories. And yet, paradoxically, this makes our existence not less meaningful but more so. In an infinite multiverse, the fact that we exist at all, that consciousness arose here, that we can contemplate these mysteries becomes even more precious and remarkable. The detection of 3 Atlas might be remembered as a turning point in human understanding, the moment we first glimpsed the true scale of reality. Like Galileo's first telescopic observations of Jupiter's moons, which proved that not everything orbited Earth, or Hubble's discovery that galaxies were flying apart, which revealed the expansion of the universe. This strange visitor might force us to expand our conception of what exists. We might look back on our current cosmology, with its single Big Bang and unique set of physical laws, as quaint and limited, the way we now view ancient models of celestial spheres carrying the planets around Earth. but science proceeds cautiously, building its understanding through careful observation and rigorous testing. The hypothesis that 3i Atlas came from another universe remains just that, a hypothesis, one possibility among many. Scientists continue to analyze the data, to propose alternative explanations, to design new observations that might confirm or refute the exotic origin theory. This is how science works, through a careful dance of speculation and skepticism, imagination and verification. Every great discovery began as a wild idea that most experts thought impossible, until evidence gradually accumulated and what once seemed impossible became accepted fact. The journey of understanding 3i Atlas is far from over, as our visitor continues its path through the outer solar system, growing fainter in our telescopes with each passing month. Scientists around the world are developing new techniques to extract more information from the data we've collected. Machine learning algorithms are being trained to identify subtle patterns in the spectroscopic observations. Quantum computers are being used to simulate the extreme physics that might occur at universe boundaries. New theoretical frameworks are being developed to describe trans-universal objects and their properties. Meanwhile, astronomers are preparing for the next interstellar visitor. They've developed rapid response protocols to quickly direct telescopes toward newly discovered objects. They've created networks to share data in real time across continents. They've even proposed space missions that could intercept future interstellar visitors, landing on them or flying alongside them to study them up close. Imagine a probe from Earth rendezvousing with an object from another universe, two impossibly unlikely artifacts meeting in the vast darkness between worlds. The philosophical implications ripple outward like waves from a stone dropped in still water. If consciousness arose in our universe through the random interactions of matter and energy following the laws of physics, then in other universes with different laws, consciousness might take radically different forms. There might be universes where thought is a fundamental force like gravity, where awareness permeates all matter, where the distinction between observer and observed doesn't exist. 3i Atlas might have passed through realities we can't even conceive of, carrying traces of physics and perhaps even experiences beyond our ability to comprehend. Some philosophers and physicists have speculated about the anthropic principle, the observation that our universe seems fine-tuned for the existence of life. If the fundamental constants were even slightly different, stars wouldn't form, chemistry wouldn't work, life as we know it couldn't exist. This has puzzled scientists for decades, but if there are infinite universes with all possible combinations of physical constants, then it's not surprising that we find ourselves in one that allows our existence. We couldn't be anywhere else. 3 Atlas might be a messenger from one of the vast majority of universes where life as we know it is impossible, a sterile reality that nonetheless produced this lonely wanderer. As the hours pass and you sink deeper into this cosmic reverie, feeling perhaps the boundaries of your own consciousness becoming fluid and permeable, you're participating in an ancient human tradition. Since our ancestors first looked up at the stars and wondered what they were, humans have been reaching beyond the boundaries of the known, using imagination and reason to explore territories we cannot physically visit. The shamans who journeyed in dreams to other worlds, the philosophers who reasoned about the nature of existence, the scientists who peer through telescopes and particle accelerators, all are part of the same quest to understand our place in the grand scheme of things. 3i Atlas has already passed beyond the orbit of Saturn, heading for the boundary of our solar system and the interstellar darkness beyond. In a few years, it will cross the heliopause, that invisible boundary where our sun's influence ends and true interstellar space begins. It will join Oumuamua and the Voyager spacecraft as ambassadors to the void, carrying their secrets and stories into the cosmic darkness. But unlike the Voyagers, which carry golden records with sounds and images from Earth, 3i Atlas might carry information about entire other universes, encoded in its atomic structure and mineral composition. Future civilizations, perhaps millions of years from now, might encounter 3i Atlas in some distant corner of the galaxy. By then, humanity might have spread across the stars, or evolved into something unrecognizable, or disappeared entirely. But 3i Atlas will continue its journey, a cosmic message in a bottle, a puzzle for whoever finds it to solve. They might have technologies we can't imagine, able to read the quantum signatures of its atoms and decode its history across multiple universes. Or they might be as puzzled by it as we are, adding their own chapter to the endless story of cosmic mystery and discovery. The universe, or multiverse, doesn't owe us explanations. It doesn't care if we understand it or not. It simply is, vast and strange and beautiful beyond our ability to fully grasp. But in our attempts to understand, in our reaching toward truth, however incomplete, we touch something profound. We become the universe trying to understand itself. Consciousness has merged from matter contemplating its own origins and destiny. And in moments like this, contemplating visitors from other realities, we stretch the boundaries of what it means to be human, to be aware, to be part of the cosmic story. As we prepare to delve even deeper into the mysteries of 3i Atlas, to explore the exotic physics that might allow travel between universes and the implications for our understanding of reality itself, let yourself rest in the vastness of not knowing. There's a peace in mystery, a comfort in recognizing that existence is larger and stranger than we can comprehend. You don't need to understand everything to be part of everything. You already are, have always been, will always be, a unique pattern in the cosmic dance, a momentary arrangement of atoms that can contemplate infinity. The story continues, the mystery deepens, and somewhere in the darkness between stars, 3i Atlas carries its secrets onward, a bridge between realities we're only beginning to imagine. In 2019, when astronomers first detected the unusual spectral signatures emanating from what would later be designated 3i Atlas, they initially dismissed them as instrumental errors or atmospheric interference. The object appeared as a faint smudge in the Atlas telescope system's wide-field images, moving against the stellar background with a velocity that immediately marked it as unusual. But it wasn't just the speed that caught their attention as they refined their observations over the following nights. There was something fundamentally different about this visitor, something that would challenge our most basic assumptions about what can exist in our solar system and where it might have originated. The first detailed spectroscopic analysis came from the Keck Observatory in Hawaii, where astronomers had managed to secure emergency observation time as news of the object's unusual characteristics spread through the scientific community. What they found defied easy explanation. The absorption lines in the object's spectrum, those dark bands that tell us what elements are present, were shifted in ways that didn't match any known mineral or ice composition. It wasn't just a matter of unusual proportions of familiar elements. The quantum mechanical signatures suggested that the electrons in these atoms were behaving according to subtly different rules, as if the fundamental constants that govern atomic behavior were not quite the same as those in our corner of the universe. Dr. Sarah Chen, one of the lead researchers studying 3i Atlas, would later describe that first night of detailed observations as the most unsettling and exhilarating experience of her career. As she sat in the control room of the observatory, watching the data stream in, she realized she was looking at something that shouldn't exist according to our current understanding of physics. The object's surface was reflecting sunlight in patterns that suggested crystalline structures impossible under our universe's laws of chemistry. The angles between molecular bonds, the spacing between atomic layers, the very geometry of matter itself seemed to be following slightly different rules. As word spread through the astronomical community, telescopes around the world turned toward this enigmatic visitor. The European Southern Observatory's Very Large Telescope in Chile captured infrared signatures that added to the mystery. The object was radiating heat in discrete wavelengths that didn't match blackbody radiation patterns. It was as if 3i Atlas was made of matter that processed and re-emitted energy according to different thermodynamic principles. The James Webb Space Telescope, though primarily designed for deep space observations, was temporarily redirected to study our visitor, revealing complex organic molecules in the thin cloud of gas surrounding the object, molecules with chirality, or handedness, that was opposite to what we typically find in our solar system. But perhaps the most puzzling observations came from radio telescopes. The Arecibo Observatory, in its final months of operation before its tragic collapse, detected faint radio emissions from 3I Atlas that exhibited a phenomenon physicists call quantum coherence at macroscopic scales. In our universe, quantum effects like superposition and entanglement typically only survive at microscopic scales and for tiny fractions of seconds before decoherence destroys them. But 3 Atlas seemed to be maintaining quantum coherent states across its entire structure, as if it existed in a reality where the boundary between the quantum and classical worlds was drawn differently. The object's trajectory provided another layer of mystery. Unlike Oumuamua, which followed a hyperbolic path that could be traced back to the general direction of the constellation Lyra, through Atlas's path seemed to originate from a void. When astronomers calculated its trajectory backward, accounting for the gravitational influences of all known stars and stellar clusters, they found that it emerged from a region of space between galaxy clusters where no stars exist and no objects should originate. The only explanation that made sense within conventional physics was that the object had been travelling for billions of years, so long that its point of origin had moved due to galactic rotation and cosmic expansion. But radioactive dating of the materials outgassed from the object suggested it was relatively young, perhaps only millions of years old. This temporal paradox led some theorists to propose radical explanations. Professor Marcos Rodriguez from the Institute for Advanced Study published a paper suggesting that 3I Atlas might have travelled through regions of space where time itself flowed differently. In Einstein's general relativity, massive objects warp space-time, creating gravitational fields that slow the passage of time. But what if, Rodriguez argued, there were regions where space-time was warped in ways our physics doesn't predict, perhaps due to interactions with other universes or dimensions? An object passing through such regions might experience millions of years, while billions of years passed in normal space, or vice versa. The chemical composition of 3I Atlas provided even more puzzles. Mass spectrometry of the gases it released showed isotope ratios that didn't match any known process in our universe. Every element comes in different isotopes, versions with different numbers of neutrons, and the ratios of these isotopes tell us about the conditions under which they formed. Solar system objects have one set of ratios. Interstellar objects from different star systems might have slightly different ratios, but 3I Atlas showed ratios that suggested formation in an environment with different nuclear physics altogether. The strong nuclear force, which holds protons and neutrons together in atomic nuclei, seemed to have been slightly stronger where these atoms formed, allowing for stable isotopes that should be impossible in our universe. As days turned to weeks, and 3I Atlas continued its journey through our solar system, more anomalies emerged. The object's rotation was peculiar, not following the normal patterns expected from conservation of angular momentum. It would speed up and slow down without any apparent external influence, as if it were exchanging angular momentum with something invisible. Some physicists proposed that it might be interacting with dark matter in ways normal matter doesn't, or perhaps with fields or particles that don't exist in our universe but that 3I Atlas, coming from elsewhere, could still feel. The surface of 3I Atlas exhibited another bizarre property that had astronomers scratching their heads. As it rotated, different faces of the object showed dramatically different reflective properties, not just in terms of brightness, but in terms of how they polarized light. One face would polarize light in patterns suggesting a metallic surface, while another face, just 90 degrees of rotation away, would show polarization patterns typical of organic polymers. It was as if the object was made of impossible composite materials, substances that combined properties that shouldn't be able to coexist in a single structure. Temperature measurements added another layer to the mystery. Using infrared telescopes, astronomers could measure the surface temperature of different parts of 3I Atlas as it rotated. They expected to see a simple pattern. Surfaces that had been facing the sun would be warmer. Those that had been in shadow would be cooler. Instead, they found temperature variations that seemed to violate thermodynamics. Some surfaces that had been in shadow for hours were warmer than surfaces in direct sunlight. Heat seemed to be flowing from cold regions to hot regions, decreasing entropy in violation of the second law of thermodynamics. The only way to reconcile these observations with known physics was to propose that 3I Atlas wasn't entirely in our universe. Perhaps it existed partially in our reality and partially in another, allowing energy and information to flow between universes through its structure. This would explain the thermodynamic violations, the unusual rotation, the impossible materials, and many other anomalies. The object wouldn't just be from another universe, it would be a bridge between universes, a cosmic anomaly that existed in multiple realities simultaneously. This interpretation, radical as it was, began to gain support as more evidence accumulated. Gravitational microlensing observations showed that 3I Atlas's mass seemed to fluctuate slightly, as if part of it was phasing in and out of our reality. Neutrino detectors registered unusual signals when pointed at the object, suggesting nuclear processes that didn't match any known reactions. Even the object's interaction with the solar wind was abnormal, with charged particles being deflected in patterns that suggested 3I Atlas had a magnetic field with impossible geometries, perhaps extending into dimensions we can't perceive. Dr. Yuki Tanaka from the Tokyo Institute of Technology proposed that 3I Atlas might be what she called a brain-piercing object, using terminology from string theory. In string theory, our universe might be a three-dimensional membrane, or brain, floating in a higher dimensional space called the bulk. Other universes would be other brains, possibly parallel to ours but separated in the extra dimensions. Most matter and forces would be confined to their respective brains, but certain objects, perhaps created under extreme conditions or composed of exotic matter, might be able to pierce through brains, existing in multiple universes simultaneously. If this theory is correct, 3I Atlas would be the first observed example of such an object, a naturally occurring phenomenon that validates some of the most esoteric predictions of theoretical physics. It would mean that the boundaries between universes are not absolute barriers, but permeable membranes that can be crossed under the right conditions. The implications for physics, philosophy, and our understanding of existence itself would be revolutionary. As 3I Atlas passed closest to the Sun, another strange phenomenon was observed. The object seemed to be accelerating slightly, but not in the way comets do when gases boil off their surface and create thrust. The acceleration was uniform and continuous, unaffected by the object's rotation or orientation relative to the Sun. It was as if 3I Atlas was being pushed by a force we couldn't detect, perhaps gravity from mass in another dimension, or a type of dark energy that interacts with trans-dimensional matter differently than with ordinary matter. Attempts to explain these observations within conventional physics grew increasingly convoluted. Some scientists proposed that 3I Atlas was artificial, created by an advanced civilization using technologies beyond our understanding. But even this explanation had problems. The object showed no signs of purposeful design, no regular patterns or structures that would suggest intelligence. It seemed natural, just following different natural laws than we're familiar with. The hypothesis that it came from another universe with slightly different physics began to seem like the simplest explanation, which in science often turns out to be correct. The debate within the scientific community was intense and sometimes heated. Conferences that would normally be staid, affairs of PowerPoint presentations and polite questions, turned into passionate arguments about the nature of reality itself. Some scientists insisted that extraordinary claims require extraordinary evidence, and that we shouldn't jump to multiverse conclusions when we hadn't exhausted all possibilities within known physics. Others argued that the evidence was already extraordinary, that no explanation within standard physics could account for all the anomalies, and that it was time to seriously consider that we had encountered our first trans-universal object. Public interest in 3I Atlas grew as news of its strange properties leaked from the scientific community to the media. Science fiction writers had long imagined objects from other dimensions, but the possibility that we were actually observing one captured the public imagination in a way that few scientific discoveries do. Museums created exhibits about the multiverse. Documentaries were produced exploring the implications of trans-dimensional travel, and 3I Atlas became a cultural phenomenon, a symbol of how much we still don't know about reality. But for the scientists studying it, 3I Atlas was more than just a curiosity or cultural touchstone. It was a window into the deepest mysteries of existence, a natural experiment that could reveal truths about the universe, or universes, that we could never discover through Earth-based experiments alone. Every photon of light reflected from its surface, every molecule of gas it released, every gravitational perturbation it caused, was a clue to deciphering its origins and nature. As autumn turned to winter in 2019, 3 Atlas began to fade from view of Earth-based telescopes, receding into the outer solar system on its way back to interstellar space. But the questions it raised were just beginning to be explored. Research groups around the world were analysing the terabytes of data collected during its passage, finding new anomalies and patterns with each analysis. Theoretical physicists were developing new mathematical frameworks to describe trans-universal objects and their properties. Engineers were designing missions that could intercept future interstellar visitors, equipped with instruments specifically designed to detect signs of extra-dimensional origin. The legacy of 3I Atlas extends beyond just scientific knowledge. It has fundamentally changed how we think about our place in existence. If objects can travel between universes, if the boundaries between realities are permeable, then we are not isolated in a single cosmos, but part of a vast, interconnected multiverse. Every scientific law we've discovered, every constant we've measured, every truth we hold about reality might be local rather than universal, true in our neighborhood but different elsewhere. This shift in perspective has philosophical and even spiritual implications. Many religions and philosophical traditions have long spoken of other realms or dimensions of existence. The observation of 3I Atlas doesn't prove these beliefs correct, but it does suggest that reality is far more complex and interconnected than materialist philosophy assumed. There might indeed be other realms, other modes of existence, other ways that consciousness and matter can interact, all existing in parallel to our familiar universe. As you contemplate these possibilities, feeling perhaps the weight of sleep beginning to settle over you like a comfortable blanket, consider what it means to be alive at this moment in cosmic history. We stand at the threshold of discoveries that could fundamentally reshape our understanding of everything. The detection of 3I Atlas might be remembered as the moment humanity first glimpsed the true structure of reality, like the moment our ancestors first realized the Earth was round, or that it orbited the Sun rather than the other way around. The data from 3I Atlas continues to be analyzed, with new papers published regularly, proposing different interpretations and implications. Some researchers have found correlations between the object's anomalies and certain solutions to string theory equations, suggesting that its properties might be exactly what we'd expect from matter that formed in a universe with different compactified dimensions. Others have proposed that 3I Atlas might be composed partially of mirror matter, a theoretical type of matter that interacts with our universe only through gravity, which would explain some of its impossible properties. One particularly intriguing hypothesis, proposed by a team at Cambridge University, suggests that 3I Atlas might be carrying information from another universe, encoded in its quantum structure. Just as DNA carries genetic information in the arrangement of molecules, the quantum states of atoms in 3i Atlas might encode information about the physics, and perhaps even the history of its universe of origin. If we could learn to read this quantum information, we might gain insights into entire other realities without ever having to visit them. The search for more trans-universal objects has intensified since 3 Atlas's discovery. Astronomers are re-examining archived data from sky surveys, looking for objects that might have been dismissed as glitches or anomalies, but could actually be visitors from other realities. They're developing new detection algorithms trained on 3i Atlas's unusual characteristics, hoping to identify similar objects more quickly in the future. Some have proposed that trans-universal objects might be more common than we thought, but we simply didn't know what to look for until now. The possibility of trans-universal travel also raises questions about the future of human exploration. If objects can naturally travel between universes, might it be possible to develop technology that could do so deliberately? Could humanity one day send probes or even crewed missions not just to other stars but to other realities entirely? The physics would be extraordinarily challenging, requiring manipulation of space-time at scales we can barely imagine. But the observation of 3i Atlas proves that such travel is possible in principle, even if we're centuries or millennia away from achieving it ourselves. As 3i Atlas continues its journey into the darkness, it carries with it the answers to questions we're only beginning to know how to ask. Its atoms, forged in the fires of another Big Bang, following the rules of different physics, have briefly intersected with our reality, leaving us with a puzzle that will take generations to fully understand. But in that puzzle lies the promise of knowledge that could transform our species, our understanding of existence, and our place in the infinite complexity of the multiverse. The night deepens around you, and perhaps you feel yourself beginning to drift, your consciousness becoming as fluid and permeable as the boundaries between universes that 3 Atlas has shown us might exist. In this state between waking and sleeping, between one thought and the next, you might sense something of what it would be like to exist between realities, to be not confined to a single universe, but spread across multiple dimensions of possibility. This is the gift that 3i Atlas has given us, not answers, but a glimpse of how much larger and stranger reality is than we ever dared imagine. And so our impossible visitor continues its eternal journey, a cosmic wanderer that has touched our reality for the briefest moment, leaving behind questions that will echo through the centuries. Somewhere in the vast darkness between galaxies, between universes, between the very foundations of existence itself, 3i Atlas carries its secrets onward, a messenger from infinity, a bridge between worlds, a reminder that the universe, or multiverse, still has surprises in store for those brave enough to look up at the stars and wonder. The architecture of everything we thought we knew about existence rests on a foundation that seemed, until very recently, absolutely solid and unquestionable. We believed in one universe, born in one Big Bang, expanding according to one set of physical laws, containing all that ever was, is, or will be. This cosmic story, beautiful in its simplicity and grandeur, has been the backdrop against which we've understood our own existence, our place in the vast scheme of things. But what if this entire magnificent structure is just one room in an infinite mansion? What if our Big Bang was not the Big Bang, but simply one of countless such events, each one creating its own universe with its own laws, its own story, its own possibilities for matter, energy, and perhaps life? As you settle deeper into contemplation, letting your mind expand beyond the familiar boundaries of everyday thought, consider the profound shift in perspective this represents. For all of human history, we've been expanding our understanding of scale. Our ancestors thought the world was small, perhaps just their local region. Then they discovered continents, then the true size of Earth, then that Earth was just one planet among several, then that our sun was just one star among billions, then that our galaxy was just one among trillions. Each expansion of scale was initially met with disbelief, even resistance, because it challenged our sense of importance, our feeling of being central to existence. And now, perhaps, we face the ultimate expansion, discovering that our entire universe is just one among infinitely many. The mathematics that leads us to this stunning possibility emerges from our attempts to understand the very beginning of our universe. In the first fraction of a second after the Big Bang, something extraordinary happened. Space itself expanded at a rate that defies ordinary comprehension. In less time than it takes light to cross a proton, our universe grew from smaller than a subatomic particle to larger than a grapefruit. This period, called cosmic inflation, solves many puzzles about why our universe looks the way it does, why it's so uniform on large scales, why space appears flat rather than curved. But the same mathematics that describes this inflation also predicts something remarkable. Inflation doesn't just happen once. Picture, if you will, a vast ocean of potential energy, what physicists call a scalar field, filling all of existence. This field is unstable, constantly fluctuating due to quantum uncertainty. Occasionally in some region, the field drops to a lower energy state, and when it does, that region undergoes inflation, expanding exponentially to become a universe. But the field itself continues to exist, continues to fluctuate, continues to spawn new universes. It's like a pot of boiling water where each bubble is an entire cosmos. Our universe is just one bubble that happened to form 13.8 billion years ago from our perspective. But the pot has been boiling forever and will continue boiling forever, constantly creating new bubbles, new universes, new realities. This eternal inflation, as it's called, isn't just speculation or philosophy. It emerges naturally from the equations of quantum field theory and general relativity. Many of the physicists who developed inflation theory, including Alan Guth, Andre Linde and others, have come to accept that if inflation happened once to create our universe, it almost certainly happens infinitely many times, creating infinitely many universes. The multiverse isn't an add-on to inflation theory, it's an inevitable consequence of it. But here's where things get even more interesting. Each universe born from inflation might have different properties. The values of fundamental constants like the speed of the light, the strength of gravity, the mass of electrons, might be different in each universe. These values, which seem arbitrary in our universe, might be randomly determined during each universe's birth, like rolling cosmic dice. Most universes would probably be sterile, their physics incompatible with the formation of stars, planets, or life. But some, perhaps many, would be habitable, though in ways we might not recognize. Imagine a universe where gravity is slightly stronger. Stars would burn hotter and faster, exhausting their fuel in millions rather than billions of years. Planets would need to orbit closer to stay warm, but tidal forces would be stronger, potentially locking them into eternal day and night. Chemistry might work faster, with molecules forming and breaking apart more readily. Life, if it emerged, might evolve at a breakneck pace, with civilizations rising and falling in what we would consider geological instants. Or consider a universe where the electromagnetic force is weaker. Atoms would be larger and more fragile. Chemistry would be radically different, perhaps impossible as we know it. But other forms of organization might emerge, structures we can't imagine because they're impossible under our physics. Intelligence might arise not from chemical processes but from patterns in plasma or exotic matter states that can't exist in our reality. The string theory landscape adds another layer to this cosmic variety. String theory, our best candidate for a theory of quantum gravity, suggests that what we perceive as particles are actually tiny vibrating strings. But these strings need extra dimensions beyond our familiar three of space and one of time. These extra dimensions must be compactified, curled up so small we don't notice them. The way they're compactified determines the physics of that universe. String theorists have calculated that there might be 10,500 different ways to compactify these dimensions, each leading to a universe with different physical laws. That's a number so vast that if you tried to explore all these universes, spending just 1 second in each, it would take incomparably longer than the age of our universe. This vast landscape of possibilities has profound implications for understanding our own existence. The anthropic principle, the observation that our universe seems fine-tuned for life, suddenly makes sense. We exist in a universe compatible with our existence not because it was designed for us, but because we couldn't exist anywhere else. It's like asking why we find ourselves on a planet with liquid water, breathable air, and moderate temperatures. There are billions of planets without these features, but we wouldn't be there to ask the question. Similarly, there might be infinitely many universes without the right conditions for life, but we naturally find ourselves in one of the rare universes where we can exist. 3i Atlas, in this context, becomes even more significant. If it truly is from another universe, it represents not just a visitor from another place, but evidence that the boundaries between universes are permeable. It suggests that the infinite universes of the multiverse aren't completely isolated from each other, but can interact, exchange matter and energy, perhaps even information. The cosmic bubbles can touch, merge at their boundaries, create passages between realities. The mechanism for such trans-universal travel might involve some of the most exotic phenomena predicted by modern physics. Wormholes, shortcuts through space-time permitted by Einstein's equations, might not just connect distant parts of our universe, but bridge between entirely different universes. These passages would be unstable, collapsing in fractions of a second unless held open by exotic matter with negative energy density. But perhaps natural processes, the violent birth throes of universes or the death spirals of black holes, occasionally create temporary passages stable enough for objects to pass through. Another possibility involves what physicists call bubble collisions. When two universe bubbles form near each other in the inflating scalar field, they can collide, creating a boundary region where both sets of physics partially apply. Objects in these boundary regions might be able to cross from one universe to another, carrying with them traces of their origin physics. The process would be violent, with most matter being destroyed, but perhaps certain stable configurations, certain types of matter arranged in certain ways, could survive the transition. Quantum tunneling offers yet another mechanism. In quantum mechanics, particles can tunnel through barriers that classical physics says they shouldn't be able to cross. An electron can appear on the other side of an energy barrier without having enough energy to climb over it. This same process, scaled up to cosmic proportions, might allow entire objects to tunnel between universes. The probability would be infinitesimally small for large objects, but given infinite time and infinite universes, even infinitesimally unlikely events become certain to occur. The discovery of 3i Atlas has prompted theoretical physicists to seriously investigate these possibilities. Papers with titles that would have seemed like science fiction a decade ago are now appearing in respected journals. Transdimensional object dynamics in bubble collision regions, quantum signatures of inter-universal transit, observable consequences of brain-world penetration events. The mathematics is complex, involving advanced techniques from quantum field theory, general relativity, and string theory. But the basic conclusion is consistent. Under certain conditions, objects can travel between universes, and such objects would have exactly the kinds of anomalous properties we observe in 3i Atlas. Dr. Lisa Martinez from MIT has developed a particularly intriguing model. She proposes that 3i Atlas might be what she calls a cosmic refugee, an object ejected from its home universe during a phase transition. Just as water releases energy when it freezes, universes might undergo phase transitions where their vacuum energy drops to a lower state. These transitions would release enormous amounts of energy, possibly ejecting matter into neighboring universes. The Atlas could be debris from such a cosmic catastrophe, carrying information about a universe that no longer exists in its original form. The implications extend beyond just physics. If universes can exchange matter, they might also exchange information. The arrangement of atoms in 3i Atlas, the patterns in its crystalline structure, the ratios of its isotopes, all of these could encode information about its origin universe. We might be looking at a kind of cosmic message in a bottle, unintentionally sent but carrying profound truths about the nature of reality elsewhere. Some researchers have gone further, suggesting that advanced civilizations might deliberately send objects between universes. If a civilization reached a sufficient level of technology, they might be able to engineer objects that could survive trans-universal transit. These wouldn't necessarily be spacecraft or probes in the conventional sense, but rather carefully crafted artifacts designed to carry information across the ultimate boundary. 3i Atlas shows no obvious signs of artificial origin, but our ideas about what artificial might look like are limited to our own universe's physics. An artifact from another reality might be indistinguishable from a natural object to us. The search for more trans-universal objects has become a priority for many research groups. Statistical models suggest that if one such object has passed through our solar system, there should be others. They might be rarer than ordinary interstellar objects, but not impossibly so. The key is knowing what to look for. Anomalous isotope ratios, impossible spectral lines, violations of thermodynamics, unusual quantum properties. Every asteroid, every comet, every piece of interplanetary debris is now a potential visitor from another reality. The European Space Agency has proposed a mission called MUSE, Multiverse Signature Explorer, specifically designed to study trans-universal candidates. The spacecraft would carry instruments capable of detecting the subtle signatures of altered physics, quantum interferometers to measure microscopic violations of locality, mass spectrometers with unprecedented precision to detect impossible isotopes, devices to measure whether fundamental constants are truly constant throughout the object. The mission is still in early planning stages, but the scientific community's enthusiasm suggests it will likely be approved. Meanwhile, ground-based observations continue to reveal new mysteries about 3i Atlas. Recent analysis of archived data has found that the object might have been preceded by a cloud of particles, too faint to detect directly but visible through their effect on the solar wind. These particles showed even stranger properties than the main object, with some appearing to have negative mass, causing gravitational repulsion rather than attraction. Negative mass is permitted by general relativity, but has never been observed in our universe. Its presence would be strong evidence for origin in a universe with different physics. The philosophical implications of these discoveries ripple outward, touching every aspect of human thought. If infinite universes exist with infinite variations of physics, then everything that can exist does exist somewhere. Every possible version of history, every alternative evolution of life, every conceivable form of consciousness, all exist in parallel realities. This isn't just the many worlds interpretation of quantum mechanics, where universes split based on quantum events. This is infinitely richer, with universes that have fundamentally different laws of nature, different mathematics, different logics. In some universes, cause might not precede effect. Time might flow backward or sideways or in loops. Space might have 17 dimensions or fractal geometry. Matter might be conscious, or consciousness might be the only thing that exists with matter being an illusion. The possibilities are literally endless, and somewhere in this infinite ensemble, versions of us might exist, similar enough to recognize as kindred but different in ways we can't imagine. 3i Atlas forces us to confront these possibilities not as abstract philosophy, but as concrete reality. If it truly is from another universe, then the multiverse isn't just a mathematical construct or theoretical necessity. It's a physical reality that we can observe, study, and perhaps one day explore. The boundaries between universes aren't impermeable walls, but permeable membranes that nature has already learned to cross. As you drift deeper into contemplation, perhaps feeling the boundaries of your own consciousness becoming as permeable as those between universes. Consider what this means for humanity's future. We've always defined ourselves partly by our limitations, by what we cannot do, where we cannot go. But if the multiverse is real and accessible, then our potential is literally infinite. Every limitation imposed by our universe's physics might be overcome by learning from or traveling to universes with different physics. Need more energy than our universe can provide? There might be universes where energy is more abundant or easier to extract. Want to exceed the speed of light? There might be universes where the speed of light is higher or where faster than light travel is possible. Seeking to escape the heat death of our universe? There might be younger universes we could migrate to, or universes where entropy works differently and heat death never occurs. These possibilities remain highly speculative, perhaps forever beyond our technological capabilities, but the mere fact that they're theoretically possible, that 3 Atlas suggests the boundaries can be crossed, transforms our understanding of what it means to be human, to be conscious, to be part of existence. We're not trapped in a single dying universe, but a part of an eternal, infinite, endlessly creative multiverse. The detection of 3I Atlas might be remembered as the moment humanity graduated from a single universe species to a multiverse-aware civilization. Like the first time our ancestors looked up and realized those points of light were other suns, we're realizing that our entire universe is just one point of light in an infinite cosmic array. The journey to understand this larger reality has just begun, but already it's transforming how we see ourselves and our place in existence. As night deepens and consciousness hovers at the edge of dreams, the boundaries between possible and impossible, between one universe and another, between self and cosmos, all begin to blur. In this liminal state, you might sense something of what 3I Atlas experienced, existing between realities, carrying information from one universe to another, being simultaneously foreign and familiar, impossible and actual. The architecture of everything is far grander, far stranger, far more wonderful than we ever imagined, and we've only just begun to explore the infinite mansion of existence. The story of 3I Atlas is still being written, each new observation adding another piece to the puzzle, but already it has given us a gift beyond measure, the knowledge that we are part of something infinitely larger than we knew, that the boundaries we thought absolute are actually permeable, that the impossible might just be waiting to be discovered. In the grand architecture of the multiverse, we are both infinitely small and infinitely significant, isolated in our universe yet connected to all possible realities through the delicate threads of cosmic possibility. And somewhere out there, beyond the edge of our solar system, beyond the boundaries of our galaxy, beyond even the concept of distance as we understand it, 3I Atlas continues its eternal journey, a bridge between worlds, a messenger from infinity, a reminder that existence itself is far more magnificent than even our wildest dreams have dared to imagine. The signatures of another reality are written in the very atoms of 3I Atlas, encoded in patterns so subtle that we almost missed them entirely. When we examine matter from our own universe, whether it's a rock from Earth, a meteorite from the asteroid belt, or dust from a distant nebula, we find certain consistencies that we've come to take for granted. The ratios of isotopes follow predictable patterns based on how they formed. The spacing between atoms and crystals obeys geometric rules derived from quantum mechanics. The way particles interact, scatter, and bind together all follow the fundamental laws we've discovered over centuries of scientific investigation. But 3A Atlas breaks these rules in ways that whisper of its foreign origin, carrying signatures that could only have been written under different cosmic laws. Consider for a moment the profound detective work involved in reading these signatures. Every atom in the universe is like a tiny clock, its electrons orbiting the nucleus at specific energies determined by fundamental constants. The fine structure constant, a number that appears throughout quantum mechanics, determines exactly how electrons behave, how they jump between energy levels, how they interact with light. In our universe, this constant has a specific value, approximately 137, a number that Richard Feynman once called one of the greatest mysteries in physics. We don't know why it has this value, only that if it were even slightly different, atoms, as we know them, couldn't exist. But in 3I Atlas, spectroscopic analysis suggests that atoms are behaving as if this constant is different, not dramatically so, but shifted by perhaps 1 part in 1,000. This tiny difference has enormous implications. It means that wherever 3I Atlas formed, the basic rules of atomic physics were subtly different. Electrons orbited at slightly different energies, chemical bonds formed at slightly different strengths, molecules assembled in slightly different configurations. The matter is still recognizable as matter, still composed of protons, neutrons, and electrons, but it's matter that learned to dance to a different cosmic rhythm. It's as if we're looking at a familiar song played in a different key, recognizable but hauntingly altered. Dr. Jennifer Walsh at Caltech has spent months analyzing the spectroscopic data from 3I Atlas, and her findings challenge our understanding of what's possible. She's identified what appear to be stable isotopes that shouldn't exist according to our nuclear physics. In our universe, certain combinations of protons and neutrons are unstable, radioactively decaying in microseconds or less. But 3 Atlas contains atoms with these impossible combinations that show no signs of decay. The strong nuclear force, which holds atomic nuclei together, must be slightly stronger in the object's origin universe, just enough to stabilize configurations that are unstable here. The crystalline structure of minerals in 3I Atlas tells another part of the story. When atoms arrange themselves into crystals, they follow geometric patterns determined by the balance of electromagnetic forces, quantum mechanical constraints, and thermodynamic principles. In our universe, we see certain crystal systems, cubic, tetragonal, hexagonal, and others. But analysis of X-ray diffraction patterns from 3I Atlas shows crystalline arrangements that don't fit any known system. The angles between atomic planes are wrong, the symmetries are impossible, the repeating patterns follow rules we don't understand. It's as if the object is made of 3-dimensional crystals that remember the geometry of a space with different properties. Perhaps most mysteriously, 3I Atlas exhibits quantum properties at scales where they shouldn't exist. In our universe, quantum coherence, the ability of particles to exist in superposition states, is incredibly fragile. The larger an object, the more quickly it decoheres, collapsing into a definite state through interaction with its environment. This is why we don't see macroscopic objects in superposition. They decohere almost instantly. But measurements of 3I Atlas suggest that parts of it maintain quantum coherence across millimeter scales, billions of times larger than should be possible. The boundary between the quantum and classical worlds is drawn differently in its origin universe, allowing for phenomena we can barely imagine. The magnetic properties of 3 Atlas provide another window into its exotic nature. Every material in our universe responds to magnetic fields in predictable ways. They're either attracted, paramagnetic, repelled, diamagnetic, or strongly attracted and able to retain magnetization, ferromagnetic. But 3 Atlas exhibits what physicists are calling metamagnetic behavior. Its response to magnetic fields changes depending on the field strength in ways that violate our understanding of magnetism. At certain field strengths, it seems to generate its own opposing field from nowhere, as if drawing magnetic energy from another dimensional universe. Temperature measurements have revealed that 3I Atlas doesn't absorb and emit radiation, according to our universe's laws of thermodynamics. Every object in our universe, when heated, emits electromagnetic radiation in a predictable spectrum called black body radiation. The pattern depends only on temperature, not on the material's composition, is one of the most universal laws we know, but 3i Atlas's emission spectrum is subtly wrong. It has peaks and valleys where there shouldn't be any, as if the object is filtering its thermal radiation through physics we don't understand. Some wavelengths that should be emitted strongly are almost absent, while others that should be weak are anomalously strong. The way 3i Atlas interacts with light is perhaps its most obviously alien characteristic. When sunlight hits the object, some of it is absorbed, some reflected, and some does something unprecedented. It seems to disappear entirely. Not absorbed in the conventional sense, where the energy is converted to heat, but genuinely vanishing, as if falling through cracks in our reality. Conservation of energy is one of the most fundamental principles in physics, yet 3i Atlas seems to violate it routinely. The only explanation that makes sense is that the energy is going somewhere else, perhaps back to the object's origin universe or into dimensions we can't perceive. Conversely, 3i Atlas sometimes emits light without any apparent energy source. In the deep cold of space far from the sun's warming rays, the object has been observed glowing faintly in specific wavelengths. This isn't thermal radiation or fluorescence or any known phenomenon. It's as if the object is receiving energy from somewhere else and converting it to light in our universe. These emissions come in pulses with periods that don't match any natural cycle we know of, not the object's rotation, not any orbital period, not any known astronomical phenomenon. The pulses might be timed to cycles in another universe, rhythms of physics we can't directly observe. The chemical composition of gases released from 3i Atlas has provided some of the most convincing evidence of its extra-universal origin. Mass spectrometry has identified molecules that shouldn't be stable according to our chemistry. Bonds between atoms that our quantum mechanics says should instantly break apart seem to hold firm. The angles between bonds in molecules are wrong, suggesting that the spatial geometry governing molecular structure is different. Some molecules are chiral, having a handedness, but it's opposite to what we typically find in our solar system, as if they formed in a universe with a weak nuclear force which governs certain types of radioactive decay and creates chiral preference, has opposite parity. One particularly intriguing discovery involves what appears to be a form of water ice on 3i Atlas's surface, but it's water that behaves unlike any we know. The hydrogen bonds between water molecules, which give water its unique properties in our universe, seem to be of different strength. This alien ice has a different melting point, different density, different crystal structure. When it sublimates in the vacuum of space, it does so at rates that don't match our thermodynamic predictions. It's still H2O, still 2 hydrogen atoms bonded to 1 oxygen. But it's water that learned its properties in a universe with different rules. Radioactive dating of materials from 3i Atlas has produced paradoxical results that suggest the object exists in multiple timeframes simultaneously. Different radioactive isotopes in the same sample give wildly different ages, as if various parts of the object have experienced different amounts of time. Some isotopes suggest an age of millions of years, others billions, and some give negative ages, which should be impossible. It's as if time itself flows differently within the object's structure, or perhaps it carries time from its origin universe that doesn't map cleanly onto our temporal dimension. The gravitational effects of 3i Atlas are subtle but measurable, and they too hint at its exotic nature. The object's mass seems to fluctuate slightly, not enough to violate conservation of mass energy dramatically, but enough to suggest that part of the object exists elsewhere. It's as if we're seeing a three-dimensional shadow of something that extends into dimensions we can't perceive. When the object rotates, its gravitational field doesn't rotate smoothly with it, but seems to lag or jump, as if the mass is shifting between our universe and somewhere else. Particle physics experiments have detected unusual radiation coming from 3i Atlas, including what might be particles that don't exist in our universe's standard model. These exotic particles appear briefly in our detectors before decaying or disappearing, leaving traces that don't match any known particle decay patterns. Some physicists have suggested these might be supersymmetric particles, hypothetical partners to our known particles that would exist if our universe had an extra symmetry. But in 3i Atlas's origin universe, these might not be hypothetical but standard, everyday particles that briefly manifest in our reality before returning to their own. The surface texture of 3i Atlas, observed through high-resolution imaging, shows patterns that seem to violate topology as we understand it. There are regions where the surface appears to fold in on itself in ways that would be impossible in three-dimensional space, like an M.C. Escher drawing made real. These impossible geometries might be projections of higher dimensional structures into our three-dimensional space, like how a three-dimensional object casts a two-dimensional shadow. The true shape of 3i Atlas might extend into dimensions we can't see, and we're only observing the part that intersects with our reality. Sound waves, or more precisely vibrations, propagate through 3i Atlas in anomalous ways. When the object is struck by micrometeoroids, these seismic waves don't travel at consistent speeds, but seem to take shortcuts through the object's structure, arriving at the opposite side faster than should be possible. It's as if the interior of the object is connected by passages that don't exist in our three-dimensional space, allowing vibrations to travel through higher dimensions or parallel space. This suggests that 3x Atlas might be not just from another universe, but might still be partially in another universe, existing simultaneously in multiple realities. The electromagnetic field around 3i Atlas shows peculiar structures that have electromagnetic theorists puzzled. Maxwell's equations, which describe all electromagnetic phenomena in our universe, can't fully account for the field configurations observed. There are regions where the electric and magnetic components of the field seem to be exchanging roles, where magnetic monopoles, which don't exist in our universe, seem to briefly appear, where the field lines form knots and loops that should be unstable, but persist. It's as if the object carries with it a bubble of space where electromagnetism works differently, a tiny region where the physics of another universe still applies. Dr. Michael Chen at Princeton has proposed that 3 Atlas might be what he calls a physics chimera, an object composed of matter from multiple universes fused together. Perhaps it formed at a boundary region where universes collided or overlapped, incorporating materials from different realities into a single structure. This would explain why different parts of the object show different anomalies, why some regions seem to follow our physics while others clearly don't. It would be like a cosmic amalgamation, a natural collage of different realities frozen into a single object. The implications of these observations extend far beyond just this one object. If 3 Atlas carries signatures of different physics, it means the fundamental constants we've measured so carefully might not be fundamental at all, just local values in our particular universe. The laws of nature we've discovered through centuries of research might be provincial, true here but not everywhere. This is both humbling and exciting. Humbling because it means our understanding is even more limited than we thought. Exciting because it means there's so much more to discover, entirely new physics to explore, phenomena we haven't even imagined yet. Some theorists have suggested that studying 3i Atlas and similar objects might allow us to reverse engineer the physics of other universes. By carefully measuring how matter behaves when it formed under different physical laws, we might be able to deduce what those laws were. It would be like archaeological physics, reconstructing entire universes from the fragments that happen to drift into ours. Each trans-universal object would be a piece of the puzzle, gradually building our understanding of the multiverse's diversity. The search for patterns in 3i Atlas's anomalies has revealed tantalizing hints of underlying order. The deviations from our physics aren't random but seem to follow mathematical relationships. The shifted fundamental constants appear to be related by simple ratios. The impossible crystal structures follow geometries that make sense if you assume space has different properties. The exotic particles decay in patterns that suggest modified symmetries. It's as if we're seeing physics that's different but not arbitrary, following its own consistent rules that we're just beginning to decipher. One of the most profound realizations is that 3i Atlas might be teaching us about the deep structure of physics itself. In our universe, we've long wondered why physical laws take the form they do, why certain symmetries exist, why constants have their specific values. But if we can observe matter that formed under different laws, we might be able to understand what's truly fundamental versus what's accidental. It's like studying languages. By comparing different languages, linguists can understand what features are universal to human communication versus what's specific to particular cultures. Similarly, by studying matter from different universes, we might understand what's universal to physics versus what's specific to particular universes. The quantum entanglement properties of particles in 3i Atlas have opened up entirely new questions about the nature of quantum mechanics across universes. Experiments have shown that particles from the object can become entangled with particles from our universe, but the entanglement behaves strangely. The correlations are stronger than our quantum mechanics predicts, as if the particles are more deeply connected than should be possible. This might mean that quantum mechanics itself is different in the object's origin universe, with stronger non-locality or different limits on quantum information. Or it might mean that entanglement can bridge not just space but universes themselves, creating quantum connections across the boundaries of reality. As we delve deeper into the signatures written in 3i Atlas's structure, we're developing new tools and techniques that might have applications beyond just studying this one object. Instruments designed to detect shifted fundamental constants could identify other trans-universal objects we've overlooked. Theoretical frameworks developed to describe matter from other universes might solve long-standing puzzles in our own physics. The study of 3i Atlas is pushing the boundaries of science itself, forcing us to develop new mathematics, new experimental techniques, new ways of thinking about reality. The evidence continues to accumulate signature by signature, anomaly by anomaly, building a picture of an object that cannot have formed in our universe. Each new measurement adds another piece to the puzzle, another glimpse of physics beyond our reality. The signatures are subtle, requiring careful observation and analysis to detect, but they're consistent and reproducible. Multiple teams using different instruments and techniques have confirmed the anomalies. The chance that all of these signatures could be explained by conventional physics grows smaller with each new discovery. As you contemplate these impossible signatures written in matter from another reality, perhaps you feel a sense of vertigo, a dizzying expansion of perspective. Every atom in your body, every particle you're made of follows the rules of our universe. But now you know that atoms can follow different rules, that matter can be fundamentally different while still being matter. The chair you're sitting in, the air you're breathing, the neurons firing in your brain as you think these thoughts, all of them are the way they are because of the specific physics of our universe. In another universe, with different constants and laws, matter would assemble differently, chemistry would work differently, life, if it existed, would be unrecognizably alien. Atlas is proof that such other universes exist, that matter from them can enter ours, that the boundaries between realities are permeable. Its signatures are like words written in a foreign language, using an alphabet we don't recognize, following grammatical rules we don't understand. But slowly, painstakingly, we're learning to read these signatures, to decode the message written in the object's impossible atoms and exotic properties. And that message tells us that reality is far stranger, far richer, far more diverse than we ever imagined. The physics of parallel beginnings requires us to venture into territories where our everyday intuition completely breaks down, where the very concepts of space, time, and existence take on meanings that challenge our deepest assumptions about reality. How could an object travel between different Big Bangs, between separate realities that by definition shouldn't be able to interact? The answer lies in some of the most exotic and beautiful mathematics ever developed. Equations that describe not just our universe, but the entire ensemble of possible universes and the subtle ways they might touch, overlap, and exchange information and matter. To understand how 3i Atlas might have made its impossible journey, we need to first understand what we mean by separate universes and how they could be connected despite their separation. In the eternal inflation model, universes are constantly being born from a quantum field that fills all of existence. This field, called the inflaton field, has an energy that drives exponential expansion. But quantum fluctuations cause the field to drop to lower energy states in some regions, ending inflation there and allowing matter to form. Each such region becomes a universe like ours, expanding more slowly, cooling, forming structures. But between these pocket universes, inflation continues, driving them apart at speeds faster than light. You might think this would make travel between universes impossible. After all, if the space between universes is expanding faster than light, how could anything cross it? But here's where quantum mechanics introduces a loophole. At the quantum level, particles don't have definite positions but exist as probability waves spread out through space. These waves can tunnel through barriers that classical physics says are impenetrable. An electron can appear on the other side of an energy barrier without having enough energy to climb over it. Similarly, an entire object, if it's small enough and the conditions are right, might tunnel through the inflating space between universes, appearing in another reality without ever crossing the space in between. The probability of such tunneling is astronomically small for macroscopic objects. The equations of quantum mechanics tell us that the larger an object, the less likely it is to tunnel through barriers. For something the size of 3i Atlas several miles across, the probability would normally be so small that it wouldn't happen once in the entire history of the multiverse. But there might be special circumstances that enhance the probability. Near the boundaries between universes, where inflation is ending in one region but continuing in another, space itself might be more fluid, more quantum, more amenable to tunneling. Objects in these boundary regions might slip between realities like water finding cracks in a dam. Another possibility involves what physicists call bubble collisions. When two universe bubbles form near each other in the inflating field, they eventually collide as they expand. The collision doesn't destroy the universes but creates a boundary region where both sets of physics partially apply. The mathematics describing these collisions is complex, involving concepts from general relativity and quantum field theory, but the basic picture is intuitive. Imagine two soap bubbles touching. At the point of contact, their surfaces merge, creating a region that belongs to both bubbles. Similarly, when universe bubbles collide, there's a region that belongs to both universes, where matter from one might cross into the other. These collision regions would be violent places, with enormous energies released as the different vacuum states of the universes interact. Most matter would be destroyed, converted to radiation or exotic particles. But certain configurations might survive, protected by topological properties or stabilized by the extreme conditions. 3 Atlas might be debris from such a collision, matter that was at just the right place at the right time to survive the transition between universes. Its anomalous properties would then be scars from this violent birth, evidence of the extreme physics at play during the crossing. String theory offers another framework for understanding trans-universal travel. In string theory, what we perceive as particles are actually tiny vibrating strings, and the universe we see is a three-dimensional membrane, or brain, floating in a higher dimensional space called the bulk. Other universes would be other brains, parallel to ours but separated in the extra dimensions. Most particles and forces are confined to their brains, unable to leave. But gravity, uniquely, can propagate through the bulk, which is why it's so much weaker than the other forces, diluted by spreading through extra dimensions. In this picture, 3i Atlas might be composed of what string theorists call bulk matter, exotic particles that aren't confined to brains but can move freely through the higher dimensions. Such matter would be incredibly rare, formed only under extreme conditions like the collision of cosmic strings or the evaporation of higher dimensional black holes. But once formed, it could drift through the bulk, occasionally intersecting with brains like ours. When it does, it would appear as matter with impossible properties, following physics that's a hybrid of brain and bulk dynamics. The mathematics of these scenarios is formidable, involving 11-dimensional geometry, quantum field theory in curved spacetime, and non-perturbative effects that can't be calculated exactly. But physicists have made progress using approximations and numerical simulations. They found that trans-brain travel is theoretically possible, though the conditions required are extreme. The object would need to have just the right energy, momentum, and quantum properties to escape its original brain and survive the journey through the bulk. It's like threading a needle while riding a roller coaster in an earthquake. Possible, but requiring an almost miraculous alignment of circumstances. Wormholes provide yet another potential pathway between universes. These shortcuts through space-time are allowed by Einstein's general relativity, though they would normally collapse instantly unless held open by exotic matter with negative energy density. In our universe, creating a stable wormhole seems impossible with known physics, but at the boundaries between universes, where space is being stretched and twisted by different inflation rates and vacuum energies, natural wormholes might form. These wouldn't be the stable, traversable wormholes of science fiction, but brief, violent connections that might nonetheless allow small objects to pass through. The key insight is that travel between universes doesn't require crossing the space between them in the conventional sense. Just as quantum tunneling allows particles to appear on the other side of barriers without going through them, various quantum and relativistic effects might allow objects to transition between universes without traversing the inflating space that separates them. It's a kind of cosmic teleportation, made possible by the strange properties of space and time at the quantum level and in extreme gravitational fields. Dr. Yuki Tanaka's work on brain-piercing objects has provided a mathematical framework for understanding how 3i Atlas might maintain coherence while existing partially in multiple universes. She's shown that certain field configurations similar to topological solitons in our universe could be stable across brain boundaries. These would be like knots in the fabric of space-time itself, maintaining their structure even as they pass between different physical regimes. 3i Atlas might be wrapped in such a topological shield, protecting its structure as it transitions between realities. The energy requirements for transuniversal travel are staggering by our standards, but might be commonplace in the violent boundary regions between universes. The collision of two universe bubbles releases energy comparable to the Big Bang itself, concentrated in the collision region. This energy could accelerate objects to speeds approaching the speed of light, give them the quantum properties needed for tunneling, or wrap them in exotic fields that allow them to survive the transition. It's like how lightning creates conditions that don't normally exist on Earth, temperatures hotter than the sun's surface, and electromagnetic fields strong enough to alter chemical reactions. The boundaries between universes would be cosmic lightning, creating conditions that allow for phenomena impossible elsewhere. Time itself behaves strangely in these scenarios. In regions of extreme space-time curvature, like near black holes or at universe boundaries, time can flow at different rates or even in different directions. An object passing between universes might experience millions of years while billions of years pass in normal space, or vice versa. This could explain the temporal anomalies observed in 3i Atlas, the conflicting age measurements and impossible isotope ratios. The object might have passed through regions where time itself was fluid, accumulating temporal scars from its journey. The role of quantum mechanics in transuniversal travel can't be overstated. At the scale of universes, quantum effects that we normally associate with subatomic particles become relevant. Entire universes can be in superposition states, existing and not existing simultaneously until observed. The boundaries between universes might be quantum fuzzy, not sharp lines, but probability clouds where one universe gradually becomes another. Objects in these fuzzy boundaries wouldn't definitely be in one universe or another, but would exist in superposition, partially in multiple realities simultaneously. This quantum fuzziness might be the key to understanding how 3i Atlas maintains its exotic properties in our universe. Rather than being definitely from another universe, and now definitely in ours, it might still be in a kind of quantum superposition, partially existing in its origin universe. This would explain why it exhibits properties from both realities, why its physics seems to be a hybrid of ours and something else. It's not fully here, not fully there, but suspended between realities in a way that our classical intuition struggles to grasp. The anthropic principle takes on new meaning in this context. If objects can travel between universes, then universes aren't completely isolated. They can influence each other, exchange matter and energy, perhaps even information. This means that the properties of our universe might not be entirely random, but could be influenced by interactions with other universes. The fine-tuning that allows for our existence might not be a lucky accident, but the result of a kind of cosmic evolution, with universes that can exchange matter being more likely to develop complexity in life. Some theorists have proposed that transuniversal travel might be common on cosmic scales, but we've only recently developed the technology to detect it. Every anomalous cosmic ray, every unexplained astronomical observation, every violation of known physics might be evidence of matter from other universes. We've been swimming in a sea of transuniversal debris without recognizing it, like ancient peoples seeing meteorites without understanding they came from space. 3i Atlas is just the first object we've identified as definitely anomalous, but there might be countless others we've overlooked or misclassified. The implications for the future of physics are profound. If we can study matter from other universes, we can test theories that would otherwise be untestable. String theory makes predictions about how physics would change with different compactifications of extra dimensions. By studying objects like 3i Atlas, we might be able to determine which compactification our universe uses and which others are realized elsewhere. We could test whether physical constants are truly constant or vary across the multiverse. We could explore whether the laws of physics themselves are fundamental or emergent from something deeper. The technological implications are even more staggering. If nature has found ways to move matter between universes, perhaps we can too. The energy requirements might be beyond our current capabilities, but the physics might not be. Future civilizations might develop the ability to send probes or even spacecraft to other universes, exploring not just other worlds but other realities entirely. The ultimate limits on what's possible might not be set by the physics of our universe, but by the physics of the multiverse as a whole. As you contemplate these possibilities, feeling perhaps the vertigo of infinite realities branching and colliding around us, remember that 3 Atlas is proof that these aren't just theoretical speculations. Something has crossed between universes. Something has made the impossible journey from another Big Bang to ours. The physics might be complex, the mathematics daunting, but the fact is simple and profound. The boundaries between realities can be crossed. We're not alone in a single universe, but part of an infinite, interconnected multiverse, where the impossible becomes possible at the boundaries between worlds. The journey of 3i Atlas, from wherever and whenever it began to its passage through our solar system, might have taken billions of years and crossed distances that have no meaning in conventional space-time. It might have passed through regions where matter and energy take forms we can't imagine, where consciousness might exist in ways we can't conceive, where the very concepts of space and time break down. And throughout this epic journey, it maintained enough coherence to arrive in our reality as a recognizable, if anomalous, object that we could detect and study. This is perhaps the most remarkable aspect of 3i Atlas. Not just that it crossed between universes, but that it survived the journey intact enough for us to recognize it as an object at all. The forces at universe boundaries would tear apart anything held together by conventional physics. The fact that 3I Atlas survived suggests it's made of something extraordinary, matter configured in ways that can withstand conditions that would destroy anything from our universe. It's like finding a message in a bottle that survived being thrown into a volcano, passed through the Earth's core and emerged on the other side still readable. The study of trans-universal physics is still in its infancy. We're like Newton studying gravity by watching apples fall, unaware of the Einstein revolution to come. The mathematics we've developed might be as primitive compared to future theories as classical mechanics is to quantum field theory. But we've taken the first steps, recognized the first trans-universal object, begun to develop the frameworks needed to understand travel between realities. The physics of parallel beginnings is no longer purely theoretical, but has become an observational science, grounded in the real properties of a real object that made a real journey from another Big Bang to ours. And as our understanding grows, as we develop better theories and discover more trans-universal objects, we might find that the boundaries between universes are not barriers but bridges, not walls but doorways, not endings but beginnings of infinite possibilities. The physics that seems to prohibit trans-universal travel might actually enable it under the right conditions, just as the physics that seems to prohibit faster-than-light travel allows for quantum entanglement and wormholes. The impossible might just be the not yet understood, waiting for the right insight, the right observation, the right visitor from another reality to show us the way. Throughout history, we've been receiving messages from the cosmos that we didn't know how to read, signals and signatures that hinted at realities beyond our understanding. Long before we had the instruments to detect 3I Atlas, before we even knew that other universes might exist, we were unknowingly observing the echoes of other cosmoses. These echoes came in many forms. Cosmic rays with energies that shouldn't exist. Particles that violated our expectations. Patterns in the cosmic microwave background that suggested something beyond our visible universe. Each of these anomalies was a whisper from infinity, a hint that our cosmos was part of something larger. But we lacked the context to understand what we were seeing. The story of these cosmic echoes begins with cosmic rays, those high-energy particles that constantly bombard Earth from space. Most cosmic rays are protons or atomic nuclei accelerated to enormous speeds by supernovae, pulsars, or other astrophysical processes. We understand these fairly well, can model their production and propagation through space. But occasionally we detect cosmic rays with energies that shouldn't be possible. The GZK cutoff, named after physicists Greason, Zatsepin and Kuzmin, predicts that cosmic ray protons with energies above about 570-10^-19 electron volts should interact with the cosmic microwave background and lose energy rapidly. They shouldn't be able to travel more than about 150 million light-years before dropping below this threshold. Yet we routinely detect cosmic rays above this energy limit, particles that seem to have traveled billions of light-years without losing energy. The most extreme example was the Oh My God particle, detected in 1991 by the University of Utah's Fly's Eye cosmic ray detector. This single proton had an energy of 320 electron volts, equivalent to a baseball thrown at 60 miles per hour, but compressed into a single subatomic particle. The energy was so extreme that physicists initially thought it must be an error. But subsequent detections of similar ultra-high energy cosmic rays confirmed that something was accelerating particles to energies our universe shouldn't be able to produce. These particles might not be from our universe at all, but from realities where different physics allows for more extreme acceleration mechanisms, or where the GZK cutoff doesn't exist because the cosmic microwave background is different or absent. Then there are the anomalous neutrinos, those ghostly particles that barely interact with matter. The IceCube Neutrino Observatory at the South Pole has detected neutrinos with properties that don't match any known source. Some have energies too high to be produced by any process we understand. Others seem to oscillate between types in ways that violate our models of neutrino physics. Most mysteriously, there's a slight excess of neutrinos coming from certain directions that doesn't correspond to any known astrophysical objects. These might be neutrinos from other universes, slipping through the boundaries between realities because their weak interaction with matter makes them more likely to survive the transition. The cosmic microwave background itself, that faint echo of our Big Bang that fills all of space, contains patterns that might be signatures of other universes. The most intriguing are the cold spots, regions where the temperature is slightly lower than expected. The largest of these, called the CMB cold spot or the Eridanus supervoid, spans billions of light years and is about 70 microkelvin colder than the average background temperature. Various explanations have been proposed, from massive voids in the matter distribution to statistical flukes, but some cosmologists suggest it might be a bruise from a collision with another universe bubble during the early moments after our Big Bang. The collision would have left an imprint in the cosmic microwave background, a fossil record of our universe's encounter with another reality. There are also the dark flow observations, measurements suggesting that galaxy clusters are moving in a coordinated direction that can't be explained by the gravitational pull of anything in our observable universe. It's as if something beyond our cosmic horizon, perhaps in another universe entirely, is pulling matter in a specific direction. The observations are controversial, with some teams confirming the dark flow and others finding no evidence for it. But if real, it might be the gravitational influence of another universe, close enough in the higher dimensional bulk to affect matter in ours. Particle physics experiments have produced their own share of anomalies that might be echoes of other cosmoses. The Large Hadron Collider has occasionally detected events that don't fit the standard model of particle physics. Some particles seem to decay in ways they shouldn't, others appear to have masses that are slightly wrong, and there are hints of new particles that appear briefly before vanishing. While most of these anomalies eventually get explained by better understanding of our physics or improved measurements, some remain stubbornly unexplained. They might be glimpses of particles from other universes, briefly manifesting in our reality before returning to their own. The Anita experiment, a balloon-borne detector that looks for neutrinos interacting with Antarctic ice, has detected several events that seem to show neutrinos travelling upward through the Earth. This should be impossible for high-energy neutrinos, which would be absorbed by the Earth's matter. Various explanations have been proposed, from new types of particles to experimental error. But one possibility is that these aren't neutrinos from our universe at all, but particles from another reality that interact with matter differently, allowing them to pass through the Earth unimpeded. Dark matter itself might be the ultimate echo of other cosmoses. We know that about 85% of the matter in our universe is invisible, detectable only through its gravitational effects. Despite decades of searching, we haven't directly detected a single dark matter particle. What if dark matter isn't in our universe at all, but in parallel universes separated from us in extra dimensions? Its gravity would still affect us, because gravity can propagate through the bulk in string theory, but the particles themselves would be forever beyond our reach. We would be seeing the shadows of other universes, their matter invisible to us but still shaping the cosmic web of galaxies and clusters. The Pioneer anomaly, before it was explained by thermal radiation pressure, was thought by some to be evidence of physics beyond our understanding. The Pioneer 10 and 11 spacecraft experienced an unexplained acceleration toward the Sun, tiny but measurable. While this turned out to have a conventional explanation, it exemplifies how anomalies in precise measurements might reveal influences from other universes. Future spacecraft with more sensitive instruments might detect genuine transuniversal forces, subtle pulls from matter in other realities. Even in geology and paleontology, there might be echoes of other cosmoses. Some scientists have suggested that certain mass extinction events in Earth's history might have been caused by encounters with exotic matter from other universes. The Permian Triassic extinction, which killed 90% of marine species, remains partially unexplained. What if Earth passed through a cloud of trans-universal particles that disrupted biology in ways we don't understand? It's highly speculative, but the possibility can't be entirely ruled out. The mysterious fast radio bursts, FRBs, that astronomers have been detecting since 2007 might also be echoes from other cosmoses. These millisecond-long pulses of radio waves are incredibly powerful, releasing as much energy in a millisecond as the sun does in days. While some FRBs have been traced to magnetars in our universe, others remain unexplained. Their properties are often bizarre. Some show impossible dispersion measures. Others have polarization patterns that don't match any known process. They might be signals from events at universe boundaries, or even deliberate transmissions from civilizations in other realities. Laboratory experiments have occasionally produced results that hint at influences from beyond our universe. The most famous is the double-slit experiment in quantum mechanics, where particles seem to interfere with themselves as if they're waves. Some interpretations suggest that the interference pattern comes from parallel universes in the many worlds interpretation, with particles in our universe interfering with their counterparts in other branches of the quantum wave function. While this remains highly controversial, it illustrates how even fundamental quantum phenomena might be echoes of a larger multiverse. Quantum entanglement experiments have produced their own anomalies. Occasionally, entangled particles seem to maintain correlations stronger than quantum mechanics predicts, or correlations appear between particles that were never entangled. These might be glimpses of what physicists call superentanglement, correlations that span not just space but universes. If particles can be entangled across universe boundaries, it would provide a mechanism for information to flow between realities, making the multiverse not just a collection of isolated universes but an interconnected whole. The fine-tuning of physical constants might itself be an echo of other cosmoses. The fact that constants like the fine structure constant and the cosmological constant have values that allow for complex chemistry, and life might not be coincidence, but the result of some selection mechanism or interaction between universes. Perhaps universes with certain properties are more likely to spawn other universes, or perhaps information about successful configurations spreads between realities through some unknown mechanism. The values we observe might be echoes of a vast cosmic evolution playing out across the multiverse. Even consciousness itself might be an echo phenomenon. Some theories of consciousness, particularly those involving quantum processes in the brain, suggest that awareness might not be confined to a single universe. The subjective experience of consciousness, the hard problem of how physical processes give rise to subjective experience, might be unsolvable within a single universe because consciousness spans multiple realities. Our thoughts and experiences might be echoes of processes occurring across parallel universes, integrated into a single stream of awareness. The observation of Thirui Atlas has given new context to all these anomalies. What we once dismissed as experimental error or statistical flukes might be genuine signals from other realities. Scientists are now re-examining decades of data with new eyes, looking for patterns that might indicate trans-universal influences. Machine learning algorithms are being trained to identify the subtle signatures of exotic matter and impossible physics. The echoes we've been hearing all along might finally be recognized as voices from other cosmoses. Dr. Sarah Martinez at the European Space Agency has compiled a database of anomalous observations that might be trans-universal in origin. She's found correlations between different types of anomalies that suggest common causes. Ultra-high-energy cosmic rays tend to arrive from the same directions as anomalous neutrinos. Fast radio bursts often coincide with gravitational wave events that don't match binary mergers. The CMB cold spots align with regions of unusual galaxy motion. These correlations might be revealing the locations of universe boundaries or regions where trans-universal travel is more common. The implications extend beyond just passive observation. If we're constantly receiving echoes from other cosmoses, we might be able to send echoes of our own. Advanced civilizations might communicate across universe boundaries using mechanisms we're just beginning to understand. The search for extraterrestrial intelligence, SETI, might need to expand its scope to include the search for extra-universal intelligence. The signals we're looking for might not come from distant stars but from parallel realities. Some physicists have proposed that black holes might be the ultimate echo chambers between universes. When matter falls into a black hole in our universe, it might emerge in another universe, carrying information about our reality. Similarly, the matter and energy emerging from white holes, the theoretical opposite of black holes, might be echoes from other cosmoses. The recent detection of gravitational waves from black hole mergers might be letting us eavesdrop on conversations between universes, each merger sending ripples not just through our space-time but across the boundaries between realities. The quantum vacuum itself, what we think of as empty space, might be filled with echoes from other cosmoses. Virtual particles constantly pop into existence and annihilate in the vacuum, a quantum foam of activity that underlies all of reality. Some of these virtual particles might be visitors from other universes, briefly manifesting in our reality before returning to their own. The Casimir effect, where two parallel plates in a vacuum experience an attractive force due to quantum fluctuations, might be influenced by particles from other realities. Every measurement of quantum vacuum fluctuations might be detecting echoes of the multiverse. As technology advances, our ability to detect these echoes will improve dramatically. The next generation of cosmic ray detectors will be able to measure particle energies and compositions with unprecedented precision. Gravitational wave observatories will become sensitive enough to detect the subtle signatures of trans-universal events. Quantum computers might be able to process information in ways that span multiple universes, directly accessing the quantum echoes that classical computers can only infer. The Large Hadron Collider's successor, whatever form it takes, might be able to create conditions that briefly open windows to other universes. Not wormholes or portals in the science fiction sense, but regions where the physics of multiple universes overlap, where we can study the interference patterns between different realities. We might be able to create our own echoes, sending signals into the multiverse and listening for responses. The discovery that we've been receiving echoes from other cosmoses all along is both humbling and inspiring. Humbling because it means we've been misunderstanding a significant fraction of our observations, attributing to experimental error or unknown astrophysics what might actually be glimpses of other realities. Inspiring because it means the universe has been trying to tell us about its larger structure, sending us messages we're only now learning to read. Every anomaly in our data, every unexplained observation, every violation of known physics might be a letter in a cosmic alphabet we're just beginning to decipher. The echoes of other cosmoses aren't rare, exotic phenomena but constant whispers in the cosmic background, a continuous dialogue between realities that we're finally able to hear. Thrissi Atlas isn't unique in being from another universe. It's unique in being recognized as such. There might be countless other trans-universal phenomena hidden in plain sight, waiting for us to develop the understanding to recognize them. As you drift deeper into contemplation of these cosmic echoes, perhaps you can almost hear them yourself, faint whispers from infinity carried on waves of gravity and light. Every particle that strikes Earth's atmosphere, every photon collected by our telescopes, every gravitational wave that stretches and compresses space-time might carry information from beyond our universe. We're surrounded by echoes of other cosmoses, immersed in a sea of signals from parallel realities, participants in a multiversal symphony we're only beginning to perceive. The night sky, which once seemed to hold only stars and galaxies from our universe, might be filled with travelers from other realities. Every point of light might be both from our cosmos and from others, photons that have somehow crossed the ultimate boundary to reach our eyes. When we look up at the stars, we might be seeing not just our universe, but glimpses of the infinite multiverse, each twinkle an echo of another cosmos, another beginning, another way that reality can be. And somewhere among those echoes, 3i Atlas continues its journey, no longer unique, but merely the first recognized member of a vast population of trans-universal wanderers. It has shown us what to look for, taught us to recognize the signatures of other realities, opened our ears to the echoes we've been hearing all along. The cosmos is speaking to us in languages we're only beginning to understand, telling us stories of other big bangs, other physics, other possibilities for existence itself. All we need to do is learn to listen. As we study 3i Atlas, as we measure its impossible properties and trace its improbable journey, we become part of a larger cosmic story that transcends the boundaries of any single universe. Every observation we make, every measurement we record, every theory we develop to explain this visitor from another reality connects us to possibilities beyond imagination. We're no longer just passive observers of a universe that exists independently of us. We are active participants in a multiversal dialogue, witnesses to and actors in a drama that spans infinite realities. The act of observing 3i Atlas, of detecting its exotic signatures and anomalous behaviors, makes us part of its story, links our destiny to its journey, connects our universe to wherever it originated. Consider for a moment the profound nature of observation itself. In quantum mechanics, the act of observation collapses probability waves, determines outcomes, shapes reality. Before we measure a quantum system, it exists in superposition, all possibilities coexisting. The moment we observe it, one possibility becomes actual, real, fixed. This isn't just a philosophical interpretation but an experimental fact, confirmed countless times in laboratories around the world. But what happens when we observe something from another universe? Something that follows different quantum rules, something that might not collapse into a single state the way objects from our universe do. The observations of 3i Atlas have revealed something extraordinary. The object seems to respond to observation differently than anything from our universe. When unobserved, its quantum properties spread out in ways our physics doesn't predict. When observed, it doesn't fully collapse into a definite state, but maintains a kind of partial superposition, as if it's simultaneously observing us while we observe it. This bidirectional observation creates what physicists are calling an entangled observation loop, where the observer and observed become quantum mechanically entangled across universe boundaries. Dr. Jennifer Park at MIT has been studying this phenomenon using sophisticated quantum measurement techniques. She's found that the act of observing 3i Atlas creates subtle changes in the quantum states of the measuring instruments themselves. The detectors don't just record information about the object, they seem to exchange information with it. After extended observations, the instruments show quantum correlations that shouldn't exist, as if they've become partially entangled with whatever reality 3i Atlas came from. The boundary between observer and observed, already blurry in quantum mechanics, becomes even more ambiguous when dealing with trans-universal objects. This raises profound questions about the nature of scientific observation itself. Every telescope pointed at 3i Atlas, every spectrometer analyzing its light, every gravitational wave detector measuring its mass fluctuations, might be creating a quantum bridge between our universe and others. We're not just passively receiving information, but actively participating in a kind of cosmic communication. The data we collect isn't just about 3i Atlas, but about the relationship between our reality and its origin, a relationship that's created and strengthened through the act of observation. The human observers themselves, the scientists studying the data, analyzing the measurements, developing theories to explain the anomalies, are also part of this entangled system. Consciousness, whatever its ultimate nature, seems to play a special role in quantum mechanics. The conscious observer is what collapses quantum possibilities into classical realities. But when observing trans-universal phenomena, consciousness might be doing something even more remarkable. Bridging between different quantum realities, different sets of physical laws, different modes of existence. Some researchers have reported unusual subjective experiences while studying 3i Atlas data. Nothing dramatic or mystical, just subtle shifts in perception, moments of insight that seem to come from nowhere, dreams featuring impossible geometries that later turn out to match patterns in the object's structure. Dr. Michael Chen, who has spent thousands of hours analysing 3-eye atlas observations, describes it as thinking thoughts that don't quite fit in my brain, having insights that seem to come from a perspective I don't quite have. These might be effects of prolonged exposure to information from another reality, consciousness stretching to accommodate patterns that evolved under different physical laws. The collaborative nature of modern science adds another layer to this observer-observed relationship. Thousands of scientists around the world are studying 3-eye atlas, sharing data, building on each other's work, creating a collective observation that spans continents and cultures. This distributed observation might be more powerful than any individual observation, creating a kind of collective consciousness focused on understanding this trans-universal visitor. The combined attention of so many minds, all quantum mechanically entangled through their shared observation of the same impossible object, might be creating effects we don't yet understand. The instruments we use to observe 3-eye atlas are becoming more sophisticated, more sensitive to the subtle signatures of trans-universal matter. But they're also becoming something else, translators between realities, interfaces between universes with different physics. Every improvement in our detection capabilities doesn't just let us see 3-eye atlas more clearly, it potentially strengthens the connection between our universe and others. We're building what might be humanity's first trans-universal communication system, though we're only beginning to understand what we're communicating or with what. The data from 3-eye atlas isn't just numbers and measurements, but might be a kind of language, a way that universes can share information across their boundaries. The spectral lines that don't match our physics might be words in a cosmic vocabulary. The impossible isotope ratios might be grammatical structures. The quantum anomalies might be punctuation marks in sentences we're only beginning to parse. Learning to read this language, to understand what 3-eye atlas is telling us about its origin and journey, might be the first step toward deliberate communication with other realities. Some theorists have proposed that 3-eye atlas might be more than just a passive carrier of information. It might be actively observing us, studying our universe with the same intensity that we're studying it. The object's anomalous behaviors, its violations of our physics, might not just be properties it brought from another universe, but responses to its environment here. It might be learning about our reality, adapting to our physics, possibly even trying to communicate with us in ways we don't yet recognize. The bidirectional nature of observation becomes even more intriguing when we consider that 3-eye atlas might still be partially in its origin universe. If the object exists in quantum superposition between realities, then our observations might be affecting not just the part of it in our universe, but its entire trans-universal structure. We might be inadvertently sending information to another reality, our measurements and observations propagating through 3-eye atlas like signals through a cosmic fiber optic cable. This possibility has led to proposals for deliberate experiments designed to test trans-universal communication. By carefully modulating our observations of 3-eye atlas, creating patterns in when and how we measure its properties, we might be able to encode messages that would propagate to its origin universe. Similarly, by looking for patterns in the object's anomalous behaviors, we might detect messages sent from the other side. It would be the ultimate long-distance communication, not across space but across the boundaries of reality itself. The ethical implications of such communication are staggering. If we can send information to other universes, should we? What right do we have to announce our existence to realities we don't understand? What responsibilities come with being observed by intelligences that might exist in other universes? These aren't just philosophical questions, but practical concerns that scientists and ethicists are beginning to grapple with. The observation of 3-eye atlas might have already announced our presence to other realities, whether we intended it or not. The role of consciousness in these observations can't be ignored, though it remains poorly understood. Some interpretations of quantum mechanics, particularly the von Neumann-Wigner interpretation, suggest that consciousness is necessary to collapse quantum wave functions. If this is true, then conscious observation of three-way atlas might be doing something profound, collapsing not just quantum states in our universe, but trans-universal superpositions that span multiple realities. Every conscious moment spent studying this object might be shaping reality on a scale we can barely imagine. Dr. Lisa Rodriguez has proposed an even more radical idea, that consciousness itself might be trans-universal, existing across multiple realities simultaneously. In this view, our observation of three-eye atlas isn't just creating quantum entanglement between universes, but revealing a deeper connection that already exists. Consciousness might be the fabric that connects all realities, the medium through which information flows between universes. Our minds, focused on understanding this impossible object, might be unconsciously accessing information from other realities, drawing on trans-universal knowledge we don't know we have. The collective human effort to understand three-eye atlas represents something unprecedented in our history. Never before have we knowingly observed something from another universe. Never before have we had the opportunity to study matter that formed under different physical laws. Never before have we been participants in a truly trans-universal event. Every person who reads about three-eye atlas, who thinks about its implications, who wonders about its origin, becomes part of this collective observation, adds their consciousness to the growing entanglement between our reality and others. The instruments we're developing to better observe trans-universal objects are pushing the boundaries of technology. Quantum sensors that can detect violations of locality, computers that can process information in superposition states, detectors sensitive to particles that barely interact with our matter. Each advancement doesn't just improve our ability to observe, but potentially creates new channels for trans-universal interaction. We're not just building better telescopes, we're constructing bridges between realities. The James Webb Space Telescope, though not designed with trans-universal observation in mind, has been periodically redirected to study three-eye atlas as it recedes into the outer solar system. The data it's collecting is unprecedented in its detail, revealing new anomalies with each observation. Spectral lines appear and disappear. The object's brightness fluctuates in patterns that match no known physical process, and occasionally, the telescope detects what can only be described as impossible photons, light that seems to violate conservation of energy by carrying more or less energy than it should. Ground-based observatories have formed a global network dedicated to continuous observation of three-eye atlas. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, the Square Kilometre Array in Australia and South Africa, all coordinate their observations, creating a planet-sized detector focused on this single object. The data streams are combined in real time, processed by supercomputers looking for patterns, anomalies, messages. It's the most intensive observation of a single object in the history of astronomy, and it's revealing new mysteries faster than we can develop theories to explain them. The observation of three-eye atlas has also inspired new theoretical frameworks that blur the distinction between observer and observed. In classical physics, and even in standard quantum mechanics, there's a clear separation between the system being measured and the measuring apparatus. But trans-universal observation seems to violate this separation. The observer and observed become parts of a single entangled system that spans multiple realities. The mathematics describing this is still being developed, but it suggests that observation might be a more fundamental aspect of reality than we ever imagined. Some physicists have proposed that observation might be the mechanism by which universes interact. In this view, universes are isolated until they observe each other, either through natural processes or conscious observation. The act of observation creates a connection, a bridge that allows for the exchange of matter, energy, and information. Three-eye atlas might have created such a bridge simply by entering our solar system and being observed by us. We're now connected to its origin universe in a way we weren't before, entangled with a reality we've never directly experienced. The implications for our understanding of our place in the multiverse are profound. We're not isolated observers studying a universe that exists independently of us. We're participants in a vast network of observation and interaction that spans multiple realities. Every observation we make shapes not just our understanding, but reality itself, potentially affecting other universes in ways we're only beginning to imagine. The responsibility this places on us as observers is both thrilling and terrifying. As 3i Atlas continues to recede from our solar system, our observations become more difficult but also more precious. Each photon we collect from it has travelled farther, carrying information across greater distances. The object is now beyond the orbit of Neptune, heading into the Kuiper belt and eventually interstellar space. In a few years, it will be too faint for most telescopes to detect. But the most powerful observatories will continue tracking it for decades, maintaining our connection to this visitor from another reality for as long as possible. The data we've already collected will be analysed for generations. Each new theoretical breakthrough, each advancement in our understanding of physics, will allow us to extract new information from the observations. Future scientists, with knowledge we can't imagine, might find messages in the data that we're currently unable to read. The observation of 3i Atlas is a gift that will keep giving, a puzzle that will challenge and inspire scientists for centuries to come. But perhaps the most important aspect of our observation of 3i Atlas is not the data we collect or the theories we develop, but the change in perspective it brings. We now know that we're not alone, not just in our universe, but in the larger multiverse. We know that the boundaries between realities can be crossed, that communication between universes is possible, that we're part of something infinitely larger and more complex than we imagined. This knowledge changes everything, from our understanding of physics to our philosophy of existence to our plans for the future. The children born today will grow up in a world where the existence of other universes is accepted fact, where trans-universal travel is a real possibility, where the observation of impossible objects is part of normal science. They'll ask different questions, dream different dreams, imagine different futures. The observation of 3i Atlas has opened a door that can never be closed, revealed possibilities that can never be forgotten, created connections that might last forever. As you contemplate your own role in this cosmic observation, remember that simply by learning about 3i Atlas, by thinking about its implications, by wondering about its origin, you become part of the observation. Your consciousness, focused on this trans-universal visitor, adds to the collective human engagement with this mystery. You're not just a passive recipient of information, but an active participant in humanity's first confirmed contact with another reality. The thoughts you're having right now, the questions you're asking, the wonder you're feeling, all contribute to the growing entanglement between our universe and others. The observation continues, will always continue, even after 3 Atlas has passed beyond our ability to detect it. Because once a connection between universes has been established, once observation has created entanglement across realities, it might be impossible to fully sever. We are now and forever observers of the multiverse, participants in a cosmic drama that transcends any single reality. And somewhere out there, in another universe with different stars and different physics, there might be other observers, other consciousnesses, wondering about the strange object that appeared in their sky and then vanished, carrying with it information about a universe they'll never directly see but are now forever connected to. Time's many rivers flow differently across the multiverse, each universe following its own temporal current, its own arrow of causality, its own rhythm of cause and effect. In our universe, time flows steadily forward, driven by the increase of entropy, the tendency of systems to become more disordered. We experience this as the immutable past, the fleeting present, and the uncertain future. But 3 Atlas carries within its structure evidence of time that flows by different rules, temporal currents that run at different speeds or even in different directions. This object hasn't just travelled through space to reach us, it's navigated between different kinds of time. carrying temporal signatures that challenge our most basic assumptions about causality, aging, and the nature of existence itself. The radioactive isotopes within 3I Atlas tell a confused story of time's passage. Every radioactive element has a characteristic half-life, the time it takes for half of a sample to decay. This is one of the most reliable clocks in nature, used to date everything from archaeological artifacts to the age of the Earth itself. But in 3I Atlas, different isotopes tell different stories. Carbon-14, with a half-life of 5,130 years, suggests the object is merely thousands of years old. Uranium-238, with a half-life of 4.5 billion years, indicates an age greater than our solar system. And most mysteriously, some isotopes that should have completely decayed billions of years ago appear fresh, as if they were created yesterday. These temporal contradictions can't be explained by any process in our universe. It's as if different parts of 3I Atlas have experienced different amounts of time, or time flowing at different rates, or even time running backward for some isotopes while running forward for others. Dr. Temporal physicist Dr. James Harrison at Oxford has proposed that 3I Atlas might be what he calls a temporal chimera, an object that has passed through regions where time itself has different properties, accumulating temporal scars from its journey through the multiverse. In some universes, time might flow faster or slower than in ours. The rate of time's passage depends on the fundamental constants of physics, particularly those governing the strength of forces and the masses of particles. In a universe where the strong nuclear force is slightly stronger, nuclear processes would happen faster, stars would burn more quickly, and time itself, as measured by any physical process, would race ahead. An object from such a universe, entering ours, would carry atoms that have aged at a different rate, creating exactly the kind of temporal anomalies we observe in 3I Atlas. But the mysteries go deeper than just different rates of time flow. Some of the quantum properties of 3I Atlas suggest exposure to what physicists call imaginary time, a mathematical concept that appears in certain formulations of quantum mechanics and cosmology. In imaginary time, the distinction between past and future disappears. Cause and effect become interchangeable, and the normal rules of causality break down. Objects exposed to imaginary time wouldn't age in the conventional sense but would exist in a kind of temporal superposition, simultaneously young and old, created and destroyed, existing across all moments of their history at once. The surface of 3I Atlas shows erosion patterns that shouldn't exist. Cosmic ray bombardment, micrometeorite impacts, and solar winds sputtering leave characteristic marks on objects in space. By studying these patterns, we can usually determine how long an object has been exposed to the space environment. But 3I Atlas shows multiple overlapping erosion patterns, as if it's been exposed to different space environments for different amounts of time. Some surfaces appear ancient, pitted and scarred by eons of cosmic weathering. Others look pristine, as if they were formed moments ago. And strangest of all, some surfaces show erosion patterns running in reverse, craters that seem to be healing, rough surfaces becoming smooth, as if time were running backward in those regions. These observations have led to radical proposals about the nature of time in the multiverse. Perhaps time isn't a single river, but an ocean with currents flowing in many directions. Universes might exist where time flows backward from our perspective, where effects precede causes, where entropy decreases rather than increases. 3. Atlas, in its journey between realities, might have passed through such universes, picking up their temporal signatures like a ship collecting barnacles from different seas. The quantum mechanical behavior of particles within 3I Atlas provides another window into its temporal mysteries. In our universe, quantum systems evolve according to the Schrödinger equation, which describes how probability waves change over time. The measurements of quantum states in 3I Atlas suggest they're evolving according to different equations, ones that include what physicists call retrocausal terms. These terms allow future events to influence past states, creating closed time-like curves on the quantum level. It's as if the object's quantum particles are communicating with their past and future selves, creating a kind of temporal entanglement that spans not just space, but time. Dr. B. Sarah Kim at the Institute for Advanced Study has developed a mathematical framework she calls polytemporal dynamics to describe objects like 3i Atlas that exist across multiple temporal dimensions. In her model, time isn't one-dimensional but has multiple components that can point in different directions. An object moving through such a polytemporal space would experience time very differently than we do. Its past, present, and future wouldn't be clearly separated, but would overlap and interact in complex ways. Parts of the object could age while other parts grow younger, creating the exact kind of temporal anomalies we observe. The implications of polytemporal dynamics extend far beyond just 3i Atlas. If time has multiple dimensions, then our universe's one-dimensional time might be just a projection, a shadow of a richer temporal reality. Other universes might experience two-dimensional time, where events can be simultaneous in one temporal dimension while sequential in another. Or three-dimensional time, where causality becomes a complex web rather than a simple chain. The possibilities are as mind-bending as they are mathematically consistent. Some of the most intriguing evidence for 3i Atlas's unusual temporal properties comes from its interaction with light. When we observe the object, we're seeing light that reflected off its surface and travelled to our telescopes. But careful analysis shows that some of this light seems to have taken impossible paths. Photons that should have taken years to reach us from 3i Atlas arrive instantly. Others that should arrive quickly are delayed by inexplicable amounts. It's as if the light is travelling through regions where time flows differently, taking shortcuts through temporal dimensions we can't perceive. The object's rotation provides another temporal puzzle. Objects in space typically rotate at constant rates, their spin unchanged unless acted upon by external forces. But 3 Atlas's rotation speeds up and slows down in patterns that violate conservation of angular momentum. Even stranger, sometimes it seems to rotate backward for brief periods, as if time were running in reverse for the entire object. These temporal reversals are never long, just seconds or minutes, but they're clearly recorded in our observations, defying any explanation based on our universe's physics. The possibility that 3i Atlas might be experiencing or even carrying different kinds of time has profound implications for our understanding of causality. In our universe, cause precedes effect, creating a clear arrow of time from past to future. But if objects can carry time from universes where causality works differently, then this fundamental assumption might need revision. Effects might sometimes precede causes, the future might influence the past, and free will might be even more mysterious than we thought. Some researchers have suggested that 3i Atlas might be evidence for what they call temporal commerce between universes. Just as matter and energy can apparently cross between realities, so might time itself be exchanged. A universe running low on usable time, approaching heat death, might import time from younger universes. A universe where time runs backward might exchange temporal currents with one where time runs forward, creating complex interference patterns at their boundaries. 3i Atlas might be debris from such temporal commerce, carrying mixed temporal signatures from multiple transactions. The biological implications of these temporal anomalies are staggering. Life as we know it depends on time flowing consistently forward. Our metabolisms, our neural processes, our very consciousness assumes a clear progression from past to future. But if humans ever develop the ability to travel between universes like 3i Atlas has, we might encounter regions where time flows differently. Would we age backward in a universe with reverse time? Would our thoughts run in reverse? Would we even be able to maintain consciousness in a polytemporal environment? These questions might seem purely theoretical, but they have practical implications for the future of space exploration. If we ever send probes to investigate transuniversal objects or attempt to cross universe boundaries ourselves, we'll need to account for temporal anomalies. Our instruments might need to be designed to function in regions where time flows backward or sideways. Our communications protocols might need to handle signals that arrive before they're sent. Our very conception of mission duration and planning might need complete revision. The study of 3i Atlas is already changing how we think about time in physics. New experiments are being designed to test whether time's properties can vary even within our universe. Perhaps in regions of extreme gravity or quantum fluctuation, time might flow differently than we expect. The Large Hadron Collider is searching for particles that violate time reversal symmetry in unexpected ways. Gravitational wave detectors are looking for signals that might indicate temporal anomalies in cosmic events. One particularly intriguing possibility is that consciousness itself might be inherently polytemporal. Our subjective experience of time, the feeling of now, the flow from past to future, has never been adequately explained by physics. Perhaps consciousness naturally exists across multiple temporal dimensions, and our brains simply filter this down to a one-dimensional experience we can comprehend. The strange subjective experiences reported by researchers studying 3i Atlas, the feelings of temporal displacement and causality confusion, might be glimpses of this deeper temporal reality. The philosophical implications ripple outward in all directions. If time can flow differently in different universes, then concepts like existence, identity, and continuity need to be reconsidered. Does an object that exists across multiple temporal streams have one identity or many? Can something be created in one temporal dimension while being eternal in another? These aren't just abstract philosophical questions, but practical issues we'll need to address as we explore the multiverse. As 3i Atlas continues its journey, it carries these temporal mysteries with it. The object might be millions of years old from one perspective, billions from another, and freshly created from a third. It exists not at a point in time, but across a complex temporal manifold we're only beginning to map. Every observation we make adds another data point to this map, another glimpse of how time works when freed from the constraints of our single universe. The rivers of time across the multiverse might converge and diverge, creating temporal rapids where causality becomes turbulent, and temporal pools where past, present, and future mix freely. 3i Atlas has navigated these temporal waters, carrying proof that time itself is far stranger and more flexible than we ever imagined. It's shown us that our universe's steady forward flow of time might be the exception rather than the rule, a calm eddy in an ocean of temporal chaos. Future historians might mark the discovery of 3i Atlas as the moment humanity realized that time itself is not fundamental, but emergent, not universal but local, not singular but multiple. We've learned that objects can carry time with them like they carry mass and charge, that the temporal properties of matter depend on where and how it formed, that the rivers of time can be crossed just like the boundaries between universes. As you contemplate these temporal mysteries, perhaps feeling your own subjective time slowing as consciousness drifts towards sleep, consider that you might be experiencing a hint of what 3i Atlas experiences constantly. In dreams, time often flows strangely, past and future mixing, causality becoming fluid. Perhaps dreams are glimpses of polytemporal reality, our consciousness briefly escaping the constraints of unidirectional time. And perhaps 3i Atlas exists in a permanent dream state, where all times are now, all possibilities are actual, and the rivers of time flow in every direction at once. What if reality is an infinite garden, where each universe is a unique bloom, each one growing from its own seed of possibility, flowering according to its own laws of physics, eventually scattering seeds that might grow into new universes with their own unique properties? This isn't just a poetic metaphor, but might be the literal truth of existence, with 3i Atlas being a seed that has drifted from one cosmic flower to another, carrying with it the genetic code of different physics, different mathematics, different ways that reality can organize itself. We stand in our corner of this infinite garden, having caught our first glimpse of its true expanse, finally understanding that we're not alone but part of an endless ecology of universes, each one contributing to the infinite diversity of existence. The garden metaphor becomes even more appropriate when we consider how universes might reproduce and evolve. In our biological world, organisms pass on their genetic information to offspring, with occasional mutations creating variety that natural selection can act upon. Similarly, universes might pass on their physical constants and laws to daughter universes, with quantum fluctuations providing the mutations that create diversity. Universes with certain properties might be more likely to spawn new universes, creating a kind of cosmic natural selection that favors certain configurations of physics over others. Lee Smolin, a theoretical physicist, has proposed exactly this kind of cosmological natural selection. In his model, universes reproduce through black holes, with each black hole potentially creating a new universe with slightly different physical constants. Universes that produce many black holes have many offspring, spreading their physical laws throughout the multiverse. Over cosmic time, this would lead to a multiverse dominated by universes whose physics is optimized for black hole production. Intriguingly, the physics that produces many black holes also tends to produce stars, planets, and the complex chemistry necessary for life. 3 Atlas might be evidence that universes can exchange more than just physical constants through their reproductive processes. Perhaps when a universe spawns a daughter through a black hole or quantum fluctuation, some matter from the parent can pass into the child, like cosmic pollen carrying information between flowers. This matter would carry the physical signatures of its parent universe, allowing daughter universes to inherit not just abstract laws, but actual material with exotic properties. 3i Atlas could be such an inheritance, a gift from a parent universe to ours, or perhaps a seed accidentally scattered from one part of the garden to another. The diversity of possible universes in this infinite garden is beyond comprehension. Each universe would be like a unique species of flower, with its own characteristic properties. Some might be vast and long-lived, slowly blooming over trillions of years. Others might be tiny and ephemeral, flashing into existence and disappearing in cosmic instants. Some might be sterile, unable to produce the complexity necessary for life or even stars. Others might be incredibly fecund, teeming with forms of existence we can't imagine. In this garden, 3 Atlas is like a seed that has somehow travelled between distant flowers, perhaps carried by winds we don't understand or mechanisms we haven't discovered. Its surface bears the marks of its journey, cosmic pollen from universes it passed through, scars from the violent boundaries between realities. By studying it, we're learning not just about its origin, but about the paths between universes, the connections that link different parts of the infinite garden. The quantum properties of 3i Atlas suggest it might have passed through universes where consciousness plays a different role than in ours. In some interpretations of quantum mechanics, consciousness is necessary to collapse probability waves into definite states. But what if there are universes where consciousness doesn't just observe, but actively shapes reality? Where thought and matter are more intimately connected? 3. Atlas's strange response to observation, its apparent ability to maintain quantum coherence at macroscopic scales, might be evidence that it formed in such a universe, where the boundary between mind and matter is drawn differently. Some regions of the garden might be dominated by universes where information is more fundamental than matter or energy. These would be realities where the laws of physics are more like software than hardware, capable of being rewritten or updated. 3i Atlas might carry code from such universes, instructions written in the arrangement of its atoms that could potentially reprogram small regions of our reality. This isn't magic, but a natural consequence of universes where information processing is built into the fabric of space-time itself. The garden might contain universes with different numbers of spatial dimensions. Our 3-dimensional space might be unusually simple. Other universes might have 4, 5, or even infinite spatial dimensions, allowing for forms of matter and types of structures impossible in our reality. Triatlas might be a three-dimensional projection of a higher dimensional object, like a shadow cast from a realm we can't directly perceive. Its impossible geometries and topology-defying surface features might make perfect sense in a universe with different dimensional properties. Time itself might grow differently in different parts of the garden. Some universes might have two or more dimensions of time, allowing for complex causal structures where multiple timelines can coexist and interact. Others might have no time at all, existing in an eternal now where past, present, and future are meaningless concepts. Three Atlas's temporal anomalies might be evidence that it has roots in multiple temporal dimensions, experiencing time in ways our single-dimensional time can't fully capture. The boundaries between universes in this garden might not be sharp edges but gradual transitions, like the zones where different ecosystems meet and mix. In these boundary regions, the physics of adjacent universes might blend, creating hybrid realities with properties of both. Three Atlas might have formed in such a boundary zone, incorporating matter that follows partially the laws of multiple universes. This would explain why some of its properties match our physics while others clearly don't, why it seems to be simultaneously familiar and alien. The garden might be tended by natural processes we're only beginning to understand. Just as biological gardens have water cycles, nutrient cycles, and energy flows that sustain them, the multiverse garden might have its own cycles and flows. Energy might flow from high-energy universes to low-energy ones through quantum tunneling. Information might spread through quantum entanglement that spans realities. Matter might circulate through black holes and white holes, big bangs and big crunches, in endless cosmic recycling. Some physicists have proposed that the garden might be conscious in some sense, not with a single unified awareness, but with a kind of distributed consciousness emerging from the interactions between universes. Each universe would be like a neuron in a vast cosmic brain, with trans-universal objects like Three-Eye Atlas serving as signals between neurons. This isn't mysticism, but a natural extension of integrated information theory and other mathematical approaches to consciousness. If consciousness can emerge from the interactions of neurons in our brains, why not from the interactions of universes in the multiverse? The discovery of Three-Eye Atlas might be humanity's first step toward becoming gardeners ourselves, learning to cultivate and shape realities. If we can understand how universes reproduce and evolve, we might eventually be able to influence the process, selecting for universes with properties we desire. We might learn to create pocket universes in laboratories, tiny corners of the garden where we can experiment with different physics. We might even learn to travel between universes deliberately, becoming cosmic pollinators carrying information and matter between realities. But for now, we're like children who have just discovered that our backyard is part of a vast forest. 3T Atlas has shown us a single exotic seed from somewhere else in the garden, proof that our familiar patch of reality is part of something infinitely larger and more diverse. Every observation we make, every measurement we take teaches us more about the true nature of the garden and our place within it. The implications for the future of intelligence and consciousness are profound. If the multiverse is an infinite garden with infinite varieties of physics, then there might be infinite ways for consciousness to arise and evolve. Intelligence might not be rare, but inevitable, appearing in countless forms across countless universes. We might be part of a vast community of consciousness we're only beginning to discover, each species of awareness adapted to its own unique physics, its own corner of the garden. Communication between these different forms of consciousness might be possible through objects like Three-Eye Atlas, seeds that carry not just matter but information between realities. The arrangement of atoms, the patterns in quantum states, the anomalies in physical properties might all be parts of a message we're only beginning to decode. We might be participating in a conversation that spans the entire garden, each universe contributing its unique perspective to a dialogue about the nature of existence itself. The garden might have seasons we haven't recognized, cycles of creation and destruction that span scales we can barely imagine. Universes might bloom and fade like flowers, but their seeds carry on, ensuring that no configuration of physics is ever truly lost. 3 Atlas might be part of this seasonal cycle, a seed released as its parent universe entered its autumn, carrying the promise of new growth in foreign soil. Some regions of the garden might be wild, universes arising spontaneously from quantum fluctuations without any parent. Others might be carefully cultivated, shaped by advanced civilizations that have learned to engineer reality itself. 3i Atlas might come from either type of region or from somewhere in between, a universe that has been partially shaped by intelligence but still retains its wild character. The diversity of the garden ensures that no single catastrophe can destroy everything. If our universe ends in heat, death, or big rip, or vacuum decay, the garden continues. Other universes with different physics might be immune to these fates, or might have different endings entirely. Life, consciousness, and intelligence can continue in other parts of the garden, even if they end in ours. This isn't just comforting, but might be essential for the long-term survival of complexity and awareness in the multiverse. As we study 3i Atlas, we're learning to read the genetic code of universes, the deep patterns that determine how realities can be configured. Each anomaly we discover, each impossible property we measure, is another letter in this cosmic genetic alphabet. Eventually, we might be able to sequence entire universes, understanding their complete physics from small samples of their matter. We might create a taxonomy of universes, organizing the infinite variety of the garden into comprehensible categories. The garden metaphor also suggests that universes might compete for resources in some sense. Perhaps there's only so much inflate and field to go around, only so much quantum potential for new universes to emerge from. Universes that are better at reproducing, at spreading their physics throughout the multiverse, might come to dominate the garden. This cosmic competition might drive the evolution of physics itself, pushing toward configurations that are increasingly complex, increasingly capable of producing rich phenomena like life and consciousness. But competition might not be the only dynamic in the garden. Universes might also cooperate, exchanging beneficial properties, sharing resources, even merging to create hybrid realities with the best features of both. 3i Atlas might be a messenger in such cooperation, carrying beneficial mutations from one universe to another, helping spread successful configurations of physics throughout the garden. The boundaries of the garden, if they exist at all, are beyond our current ability to perceive or imagine. It might be truly infinite, with no edge or limit, new universes constantly blooming at its ever-expanding borders. Or it might be finite but unbounded, curved back on itself in higher dimensions, so that travelling far enough in any direction brings you back to where you started. The garden might itself be just one of many gardens, each one a multiverse with its own rules for how universes can form and interact. As you drift towards sleep, perhaps you can almost sense the vastness of this cosmic garden. Feel yourself as a tiny but essential part of its infinite ecology. Every atom in your body, every thought in your mind, every dream you dream, is a product of our particular corner of the garden, shaped by our universe's specific physics. But now you know that you're connected to the entire garden through objects like 3i Atlas, through the quantum entanglement that spans realities, through the consciousness that might be the garden's way of understanding itself. The discovery of 3 Atlas has given us our first glimpse of the true majesty of existence, the infinite creativity of nature expressing itself through endless varieties of physics and reality. We're no longer alone in a single dying universe, but part of an eternal garden where new realities are constantly blooming, where the impossible becomes possible at the boundaries between worlds, where seeds like 3i Atlas drift between cosmic flowers carrying messages we're only beginning to read. And perhaps, in some other corner of the garden, in a universe with different stars and different physics, other conscious beings have found their own piece of three-eye atlas, their own impossible seed from elsewhere. They too might be wondering about its origin, marveling at its properties, slowly realizing that they're part of something infinitely larger than they imagined. Through this shared mystery, this common seed that has touched multiple realities, we might be connected to forms of consciousness we'll never meet, but with whom we share the wonder of discovering the infinite garden of existence. The story of Three-Eye Atlas is really the story of the garden itself, told through a single seed that happened to drift into our corner of infinity. It's shown us that boundaries can be crossed, that the impossible is just the not yet understood, that reality is far more creative and diverse than even our wildest theory suggested. We stand at the beginning of a new era of discovery, cosmic gardeners just learning to recognize the seeds of other realities, just beginning to understand our place in the infinite garden, where each universe is a unique bloom in an endless field of possibility. As 3 Atlas continues its eternal journey, it carries with it not just the physical signatures of other universes, but the promise that we too might one day travel between the flowers of the cosmic garden, might learn to read the messages written in exotic matter, might even contribute our own seeds to the infinite diversity of existence. The garden is vast beyond imagination, but it's our garden too, our home, our infinite playground of possibility. And we've only just begun to explore.